Twitch, YouTube, and LinkedIn. So if you're with us on Crowdcast and you're new to Crowdcast, which some of you have already told us you are, a little bit of information for you. There's a follow button in the top right-hand corner. There's a green button there. There's the chat at the bottom where it says say something nice. You can let us know where you're joining us from today. I already see lots of people messaging in. We've got people from Morocco and Germany and the UK and Switzerland. Welcome to you. We also have some polls at the bottom of the screen and the opportunity to ask a question that will go to our speakers, and that's for questions related to their talks. So you can chat with us and ask questions there. We'd love to hear from you. There's also a green button at the bottom of your screen where you can sign in or sign up for your cloud account and follow along the hands-on workshops today. So today we've got another great 4 sessions, and I'd like to pass it over to Liam. Liam, welcome. So glad you're joining us today.
Hello. It's nice to be here again to the 3rd and final day of the Developer Festival. It's really exciting. Yesterday and Monday we had some fantastic talks, and today is absolutely no different. Today is all about cloud. My name is Liam Hampton. I am a developer advocate in the UK team, and I'm going to be helping Miriam with some hosting today for this festival. And first up, we have got Thomas, and Thomas is going to take us through how you deploy a microservice app to a serverless framework. So with that being said, Thomas, we will hand it over to you. We'll turn our microphones and cameras off. And if you have any questions, pop them in the ask a question box at the bottom or put it into the chat and we will answer as we go or at the end. Okay, over to you, Thomas.
So awesome, Liam. So thank you very much. And yeah, a very warm welcome. Yeah, starting with the easy stuff, I would say, because we were doing a jump start, deploying a microservice-based application to the serverless framework. So my name is Thomas Südbrücker. I'm a developer advocate, as I said, and the reason why I created that workshop is that I want to figure out some promises which this platform made based on containerized applications, so that we will take a look later on, because I did with my colleagues some examples for microservices-based applications. It's called Cloud Native Starter, and the Cloud Native Starter application focus on basic cloud native development and reactive and security. And we did some samples, and I just wanted to run that one of that sample, the security sample, on that platform. So a little bit about the prerequisites. Yeah, what you need an IBM Cloud pay-as-you-go account, but you don't have to spend money. We will see it later, but you need a pay-as-you-go account. You need obviously a browser. Yeah, I guess depends on which platform you are watching. Yeah, normally you would have a browser and internet access for sure. And it is good that you have a basic understanding of containerized applications, not in depth. Everything, the source code and all is in the GitHub project. I will also show you, but it's not needed because we will deploy existing containerized application. Okay, with that, oh, that was the wrong direction. Yeah. Go forward. Yeah. When I say what we are using with this serverless framework is the IBM Cloud Code Engine, a managed serverless platform built on open source technologies, and that's important to know there. It's first on Kubernetes, and maybe you know that Knative is based on Kubernetes, which makes these all really serverless, so that you really can scale down to 0, Istio for routing stuff, and Tekton. And with that in mind, and that is the reason why I say that is the easy start, because a big advantage when we use that, we have not to take care about cluster management, and it's truly serverless because it really scales to 0. And with that, we go forward. What is the objective in that workshop? Really, we want to deploy these existing microservices based application, and we use the code engine CLI. And I got the promise from from the product management. They said, yeah, you don't have to specify any YAML. Yeah, so, and I want to check it out, and yeah, I can already say that's true, and it's much easier for doing that. You can use the code engine CLI, and everything is working. Yeah, otherwise we would not do that workshop. So, and what is also important to know when you have containerized applications and microservices application, you don't want to give the routing to every single application instance you have, also to external. So there's some internal routing, and I also want to check that and how that works. And we will see this also. That is also an objective of that. And for sure, if you running application, you need some kind of monitoring, and this is also given with out of the box. So we will take that, how is this integrated out of the box monitoring and logging for the application. And what I also do, and that was also the reason why, because I also have a private paid account. Yeah, I do not run so much on that paid account, but I really also want to double check how this works on my account, so that I will show you how to set all of that up all of that in my private personal account. So okay, the example application. Yeah. What we will deploy, a short overview of that. First of all, when we have an application, yeah, we have a front end, and this application front end will be hosted at first on code engine. So there's an Nginx server, yeah, and when you open up your browser and you access this web application, which is implemented in Vue.js, yeah, you load these in your browser, and so the instance runs in the browser. So, and with all of that, yeah, we need a route, yeah, to access this web application, yeah, with the Nginx, so that is provided to us, so that we can load it in the browser. So this is one external routing, and then we use for the identity and access management Keycloak, and Keycloak is running also on the code engine. This is an example application. You should not run it here. Yeah, so that's not designed, but that's example application. Also, what you see, there's a lot of logging information in the source code you have, so that it's not for productive. It's just for example and to understand all that stuff. So for sure, the web application needs to access the identity and access management, because the identity and access management will provide us the UI for the login and provides us some access and identity tokens. So we will use later on here when we're going to access the web API microservice. The web API microservice provides us the information about articles. So we will see in a few moments the application live, because I have already also running instance, so that you can see, yeah, keep the end in mind, what will be deployed, so that you can really see it. And we will invoke it with the access token, and the token must be verified at the Keycloak, so that we need here the external URL. So I use the external URL to verify that. And then we have what I said, that currently we have already all these external routing, but now it's time for internal routing, because we have here microservice which provides the information about the articles, so that we will go to present on the web front end. And with that, we don't want that these can directly be accessed. So, and this is an internal routing. So we have here. So that is the internal routing. So, and nobody can access that, and so that you can see that that can be ensured. But we verify the token and so on with the external routing here. So, and now it comes to the question scale to zero. So maybe you have used IBM Cloud before, and if you have used it in some cases and some examples, maybe also with the Cloud Foundry stuff, yeah, which is also easy to use. But if you maybe forget your application, yeah, that is running, yeah, it doesn't scale down, and you have to pay for. And that is a thing from my personal perspective I had, so that why it's also interesting for my private usage, so that I can really say, yeah, it scales down, yeah, and I really can define what is the maximal amount of the instances. So here I say scale to 0, yeah, here for web application scale to 0, that we have that here. This is a special situation. Keycloak is not allowed to scale to 0 because we will set up and do the configuration, and the container, yeah, is configured. And in a moment when the container restarts, we will not have all these configurations. So we keep that alive. That is in that case, and yeah, the rest can scale to 0. And also to understand and to see is each application can be configured differently in the size of amount of CPUs and consuming memory. Yeah, and that's great. So, and with that, yeah, I go to the live application that you can see the example. So that's the running example I have on an IBM instance here running. So later on we will log on as Alice, and that's the login screen we have here. And now I try to log on, and what you see here, I use the Safari, and I have enabled the developer tool so we can see what the traffic is. So not now, not for this website. So we go back. So now there was too many bags. Yeah, I prepared it, and it took maybe was too long in a situation that it slept too long. So, and then I need to, here, where's this? That's live. You can see here. Where's my? Yeah, I need my prepared. That's okay. I have to start once again. So here, that's my current IBM Cloud account. Yeah. And I now need to restore my example. So I need the link to my own repository or the example here. So maybe, Len, can you directly post the code for the link in the here in the chat, so that I can also take a look here. Yeah, sometimes that happens. So now going back. So my projects. I haven't. I just working on my second screen, so I currently try to get the link for the application I want to show you. So that's the application I want to show you here. Yeah. Now we go. Now we're going to try this here. That is. Yeah, and at least this is all what it does. So, and what I did here, I showed web inspections, JavaScript console. And yeah, here you can see here, you can inspect what happens behind the kernel. That what I said. I get the access token here, yeah, And I provide some additional information here in the example application that is what you get when you run that example. You can really see how the application works. So, and with that in mind, so I now need this link to my workshop. So I got that thing now. So that's the same way you can access the workshop. So I create a new window so that I can just move through the windows. And if it's too fast, yeah, for moving all that stuff, please give me a short notice. Yeah, so if it's too fast, or maybe it's also too slow, then just give me a short feedback. So here you see the overview. It's mostly like what we already did, yeah. And here's the example with the architecture and all that stuff, yeah. Information you can see, and down the bottom, yeah, you can access here the full workshop. And there is also a recording here. I also gave a short talk in the IBM Expert, Let's Code. And here you can see why I said that you will not pay any money, even if you have the paid account, because there's a free tier. For sure, if you are over that free tier, yeah, then you would pay money, but I do not expect that when you follow these steps, that you really pay for anything here. And we're also doing logging and monitoring with IBM microservices, with IBM Cloud Services, and they have a light plan, and the light plan doesn't create any costs. A little bit information about light plans is that you can have one instance of this service, yeah, with a limited functionality, but you can ensure that you don't have to pay any money for that. Yeah, as I said, it's okay when you are a beginner, yeah, but you should have containerized a basic understanding of containerized applications, and that is once again with all this architecture. Here you can see a list what is important to know about the configuration. Yeah, and with all of that, yeah, we can go to the lab information. And if you want to take a look at the source code and so on, yeah, here once I just want to open up it in a new tab. So that's the source code. And if you really want to dig in, how is this implemented? Yeah, everything is given here, and you can take a look at that. And what is really useful, because what I did really is not so complicated for you, and easy also for me, is writing bash scripts. And we will utilize bash scripts, which are here, and you can examine them, which does everything automatically. Yeah, so the entire application is set up automatically to Code Engine, all the configurations. So at the end, you have this running example. You can inspect the application. So that's the reason why you don't have to be an expert in that. Yeah, you can learn on that example, or with that example. Okay, so let us go to the labs. So the first lab is set up the example. I would say, because it is so easy to set up all that stuff, that you should just simply watch what I'm doing and then do it by yourself. I noticed that it's challenging if you both at the same time, yeah, watching and working, and maybe you miss something. And that's the reason why I would say, yeah, take a look at it, how it works, maybe watch also the replay. It does not mean that you're not allowed to do it at the same time. Just do it, and or watch it. Yeah, so here is for the setup, once again, with the pay-as-you-go account, I give you here some insights about the pricing, what is free and what is not free, and about the calculation we will see later. Create a code engine project in your account. So that's also defined here, how to do that. I already have an, where is it here? That's my account here. You can see I already have a log analysis and a monitoring instance of these IBM cloud services. Yeah, so what we will use later. And I also have already here a project which is called here Cloud Native Starter, so with an ending. Now that is what you later will create. It's easy to create. You have just to move there. Everything is documented here. Yeah, I also did it or did insert some links. So, and you are logged on. These links directly guide you where you should go, and you don't have to navigate. So that's easy. Yeah, when this is running, so we come to a topic which is nice for executing workshops, because we can use the IBM Cloud Shell. The IBM Cloud Shell provides us a shell for working on with CLI commands and pre-installed tools on the web. And it is also cool because you're already logged in. You don't have to log in again. Yeah, what you normally, what you must do when you're working from local. So you are already logged in. So when I created the shell script, so I didn't have to take care about all that stuff with log on and all that stuff, because this is already given. And this is what we are going to use. So that means here we are going to start. So that is what I will do here. Where is it? Where is that's here. I will now open up for that the Cloud Shell. So that's here. Now we're going to access the Cloud Shell. So that open up and use the new tab. I can close this other application. So it takes a while. It prepares the session for you. I have to take a look how many pages I have here. I can close that. So this is okay. I will close that session. And then I will close that. So now we're here. Yeah, and now we take the advantage with copy and paste stuff. With the fact that you can just copy and paste here, but because, just a little bit background, I wrote the documentation here with mkdocs, which does automatically this very useful outline. So, and you can directly copy and paste all that stuff. So it's here, so, and just copy it. It clones the GitHub project to the Cloud Shell instance. Yeah, and here, what I also really like to utilize are environment variables in the shell here later on, and that's the reason why I save here the path, so that everything runs later on very smooth. Okay, let us go here, and just it's more about copy and paste, and that is what you need to do, or might need to be able to do, at least copy and paste. That's your challenge is understanding. Yeah, it's the understanding. So now we're here, and now we copy and paste an additional variable, and this variable is the project. So, and here I know my project is TS, so just verify it once again. So the name is TS, because I grab, when we invoke later on the shell script, I grab that variable, and I take it and I set up the information based on that. So that is important that you have set these variable, right? So with these in mind, yeah, we can go to the next step. And the next step is is executing and watching, because now we are going to deploy everything. So when we are going to deploy that bash script, by the way, when we see here, I also provide you a link to the bash scripts, and the implementation here can directly move here so that you can directly see what is the content here of the script and how does it work. So maybe make it a little bit not smaller, it's a bit bigger so that you can see it here. And here also maybe that you can see it here. Okay. Yeah. And we just now can copy these, and these are the variables you should care if you want to customize it. Yeah, that's great. And now go back. That's all given here. And now we can say here, execute, and it will start with setting everything up. So you can see here now it's getting the project information and so on. Yeah, and now we will also take a little bit a short look behind the curtain. What does this script? Yeah, simplified steps which are carried out here in that script. So we connect to the Code Engine project. Yeah, we get the namespace, and that is important to know. The project is at least a namespace in Kubernetes in native. And that's the reason we have all these pods or pods, all these applications inside that namespace. And this is also with the internal routing. Yeah, so we have these, and those that we can work. And for a small application, I think that is really very, very useful if you want to get want to start or set up an application here on Code Engine very fast and try out, or maybe also for productive usage. Yeah, it is perfect because you don't have to do all these management stuff with the clusters and so on. That's good. So here, that was a little bit background about this with the namespace, and then it deploys the app. First, we deploy the web application. That is a little bit now about the order, why I did some steps here in the bash script. Is first, I need for a Keycloak a redirect URL so that Keycloak really can verify that the request for a login is from a valid source and provides it. So, and that's the reason. So I need that URL from the from this web application. So with that, when I got that, I can deploy the Keycloak, yeah, and then provide the Keycloak the information with environment variables. So when we go here, okay, let me see, where is the? I can see here. I see here at the moment it currently configures Keycloak, for example. Yeah, you can see here I do all these steps. That means we need to know the order, and I see here also the URLs which are provided. Yeah, so the Keycloak URL, for example, and so on. And I grab that inside the scripts. So here the deploy script. And nice to see is that this is the invocation, yeah, to create an application on Code Engine. So the promise is fulfilled. That means I have not to define any YAML. Yeah, I need to know the parameters. Yeah, but it's true. Yeah, that's easy. I don't have to take care about maybe also with some config maps and all the on. For that, it does that's everything for me. But the cool thing, if I want to do that, I can do that because I also have the ability also to access and use the kubectl, for example, because as you can see in when in the running script, I also utilize these commands just to verify some additional information just for myself. So it's not needed because it works also only if you execute only the IBM Cloud Code Engine CLI. Yeah, so obviously, and yeah, so that is all I need to do. And here I get, yeah, that is what I do here. And you can see I did the separation here in functions here for the execution of the bash script. And you can see here that's the execution itself. You can see how the execution will be automated. And this is what we are seeing here. Oh yeah, for all that stuff, and it runs through. Yeah, we can take a look in our project. You can see currently we have at the moment 3 applications. Now we take a look into the application. It's deploying once again the web application. So and I was starting here. So give you the feedback on that. Just go back on track, so not to lose yeah the direction I want to give you. The background we did connect to the project, get the namespace, deploy the web application to get the root, configure a key cloak, yeah, and deploy an articles application, because the articles application, as you maybe remember, is the application which runs inside Code Engine. That means it has a local cluster as a parameter. So these service we need for our web API, because the web API invokes that service, and later on, the web app invokes the web API to get the articles, because the web API will provide the articles information, and the web API needs also the key cloak URL to get it, and that's the reason why is this order needed. So to set up the running application. And by the way, when you take a look at the first implementation of the bash script, I gave the parameters with the environment variables, or with the for the key cloak, for the user and password information. Yeah, that should not be in clear letters normally. So the cool thing is you can also do that with the secrets, and the bash script with that does the same thing, just creates an additional secrets. But I don't want also to cover that in the first approach. So with all of that, we have everything deployed. You can see here the articles staged to 0. Yeah, and our, let us take a look in the Cloud Chain. So here at the end, you see here we have the key cloak URL. We have all these URLs here running, and can copy it and then open up. And then we can see here one instance currently running. Articles is not running, so we can guess if we want to access that, it will not work, because get the articles information I meant, because it is not running, so we cannot provide articles information. So you can see here the web application has routed to the key cloak, The RAM inside Keycloak, that is where you configure all this security stuff, is also automatically configured, because Keycloak does have a very good concept of that it just provides you some config files you can for the RAM, and you can import them, and I took usage of that. So now it will take time because in the background the article service is not running, so we need to invoke it very often so that the articles service will start up. Or what we also can do, and that is in that situation I will do that, because the article service really takes sometimes a bit. Here I change the configuration. Now I'm in the application. You can see the running instance currently is not a running instance. Yeah, here I changed the configuration. That's not a part now of the workshop. It's just in addition here for the live version. So I will change here very easily the runtime, because currently I have minimum on instances maximum 0, scale to 0, but I don't want to that because it took too much for me. And here you can see the environment variables, which are provided by myself and which are out of the box of Code Engine. Here you can see the subdomain, which is here the namespace, and here we go to change it. The runtime. Now we can see when this is enabled for change. I just do that and save, just to make that a little bit easier. So when you do again and again these updates, yeah, we'll see that it will work and will show us later on the articles which are available with that example. So, and yeah, with that everything works, and it was easy to deploy, and it works in the same way as it worked in on Kubernetes and on OpenShift. Yeah, so it was easier to deploy. Yeah, easier to deploy. I mean, from the perspective that I had not to take care about all these YAML stuff. I know what I want, and so that's a good entry point if you're only familiar with basic container functionalities. Yeah, and then it's a good starting point to do that. Yeah, and run a containerized application also with the capability scale to 0. So this is what I said here is the running application. Going back here, that is what we did. Yeah, we can see here everything is very clear. This documented in the documentation, in the workshop documentation, I guess. And if you have any feedback to provide, hey, please provide it. And if you find some things I should correct, or maybe I don't understand, hey, feel free to create an issue and yeah, just provide it. So once again, the lab. So now inspect the Code Engine project. So we already did some of the inspection, which you are guided through when you follow the steps here. You already have seen here the overview. So that is here when I go back to the project. The overview. This is the overview we have. Yeah, and when we go down, you see the applications. Here, these are the applications, so we can directly open the routes. There are the external routes available, so we are directly guided through. And this is a short change. Yeah. Oh, it's nice to see the involvement and the and the progress of Code Engine they introduced some additional information for the application. So when you're now access an application, for example, this web API, yeah, you can directly see the first stuff, what you're interested in. If you want to stage to zero, yeah, is my application currently running or not? Yeah, you can see the configurations. That means what you notice. I changed the number of instances, and that's a new configuration, the code engine. And then here you see the configurations which are available here on that. And that's the direct overview. Then we have here the configuration itself. Yeah, what is the current configuration of that application? You can see where does the container come from. I use Quay here, and this is the repository. You can get the container, the runtime. You see here the runtime with CPU and memory, and when you take a look at the configuration, I also provide the information in the workshop documentation directly guide you through. There's a combination, yeah, which is a layout so that you have a combination between CPU and memory you can select. So once again, here are the environment variables and commands to override. Yeah. That means what you can see here in the documentation. Now, this is what we already have seen here. If you are familiar with building your container, then you know you have endpoints and the CMD commands. It's how you access the container and so on. Then here you can override maybe some commands which are related to your container creation. Because what we currently do not cover, yeah, I really cover only the topic deploy an existing container, but you also can deploy at least source code, and the container is built for you. Yeah, and in that case, it is very useful to have these override commands. Yeah, and what I really also like is that now there have also on the front end here on the UI that you can see here the endpoints. Here you can see that's the public and the project only. You can switch to when you want to, and yeah, that's very useful. So you know we have one service which does not use the public. This is the article service. So go back, and then we have here once again the description. Yeah, how is everything here configured? And now what is also directly accessible and very useful. Yeah, for sure. You want to know what does it cost, and you can directly access here the estimate costs. And here I take Germany, and here you can see the combination. So for this is 0.5 CPU, and if I would run it 1 day in a month with yeah, I would say with one instance, yeah, and then I can say this would cost me €2.70. Yeah, you can play around with that so that what does it cost for you, and you have to decide what is your break-even point using a cluster or not. Yeah, and as I said, what you also have to calculate in addition, yeah, it is really easy of use from my perspective, and this is also a topic. Here is also a capability you can use to test the application. That means at least testing, you can have requests and can send a request to the application here, and with that it shows you what the response is, and it depends how you have implemented your application. What does it respond? You can verify it also here. But you have also to see test the application in combination with the logging, and that was the bridge also to the logging topic. It takes a little bit because I guess it has to scale up. I can see it was down, and that takes a little bit. So yeah, now monitoring. If you haven't the monitoring already created, the monitoring services, I also wrote a script here for the creation of the monitoring services. You can execute from the cloud, and it does create the two services for you. You can also see how does it work. Yeah, with all of that stuff. Excuse me. So, and I already have this created, so that means I don't need to execute that script, and I can just follow the steps which are written here, and I can verify if the monitoring here is available. So here I go to the overview, because I now will access the monitoring directly from here, so that I can monitor everything which is here. And it depends a little bit, because I am currently running out of the time. There's for the monitoring, there is also a trial time, yeah, and in this trial time you have some more capabilities, and later on you have the light version, which has some additional restrictions. And here you can see here we have the number on applications revisions here. We can see here the application overview from the scaling perspective and so on, and the application concurrency. Yeah, so we can see here, for example. Okay, awesome. Easy to access. Yeah, you can inspect by yourself. You can configure the monitoring. It is here provided for you. And the next is using logging. It's the same procedure as before. What I like with the logging here is you can get a very, very easy overview of different instances. That's also to the monitoring itself. It's not only related here to the, just to keep in mind, it's not only related to the code engine. It is, you can monitor here everything which is inside the cloud, and also other resources. Yeah, so it's not bounded only to that what I currently showing you. But the cool thing is that it's out of the box integrated. Yeah, and I also provide a section to set up these manually, which gives you the ability to get more insights how this setup works. So, and when we go to the logging, going back here, logging. Which utilizes the log, it's built on log DNA. Yeah. So, and you can see here that is pre-configured. We have the platform code engine, the project label, yeah, which is, and we see information which comes out. It takes a little bit, yeah. And currently, I do not have, we don't have traffic, so we need to create some traffic here. Is where's the application running? Toolchains, so maybe start a web application. Just create some traffic. That was the, it takes a little bit. It takes a little bit time, yeah. Well, what I want to move forward also in the configuration, because what I did in that context, what is interesting for you, you can see here also how the configuration works with the sources. So what I said here, that's the source and that's the code engine. That's all, as I said, that's already provided here, but we can do that special also for that. So now it's set that the code engine, that is our source. And what we also are going to do, I copy just that frame here and say here. And with that, I know, because everything now, when any information comes, which is related to the application from my personal logs, yes, because the console output is given from the container information also. And then you can directly see how the application inside works, because I did logging to that you can verify. Where is it? 10 lines. Now you can see here what is invoked. Yeah. So what is invoked? Get articles, add articles, add samples, so that you can also take a look directly in the code itself. So the structure of the log is that you can see here the class, yeah, and the method I invoked here, and with some additional information. Yeah. So we're very close to the last step. Where's the line? Going back to the documentation, you can see here. So here I also created a short GIF. And then you can clean up to prevent that you take, it will create any additional cost for you. So I only delete all the applications inside the code engine. That's also available with a script. Yeah, if you're not already have logged on, so that's what you need to do, and you have a remove script. So with all of that, then you have done, and you have fully, executed that workshop, and you can inspect even more. Yeah, and here I also provide additional resources, what you can see with some information from the Cloud Native Startup project, what I said, where I come from, where this example came from, and some additional labs is about run maybe also that example locally. Therefore, you need to set up some additional tools and so on. It's not not designed these optional labs to run it from the code from the cloud shell. Yeah, so and also maybe how to deploy your own versions of that applications to the registry and so on. And what's new also? Yeah, that's a little bit new. So I also did a configuration that I replaced the key cloak stuff for the authentication authorization with FID. Yeah. And with that, the cool thing is you can just instantiate the application, the entire application, and everything can scale to 0, so there are no additional costs. So let us summarize from the perspective what we wanted to achieve. Yeah, going back here. Go back. So we wanted to achieve to see how the existing microservices containerized application, how to deploy it. Yeah, it was very easy. For sure, you need some additional work to do with that. What I did with this writing the bash script. Yeah, but at least, as you can see, we can do really everything with the code engine CLI. So we do not have to configure any YAMLs. Yeah, we need only to know the code engine CLI. The internal and external routing, we have seen that also works, so that we really can deploy an application, yeah, and maybe we only have one external route, yeah, to the application itself, and we have different functionalities which can scale down, yeah, inside our application because it's not needed in our productive situation. So that's also very good. And we have out-of-the-box monitoring in place, which is directly bounded out of the box to code engine. So everything is achieved. And once back, we do not have to do the cluster management, and it's truly serverless, as you have seen. It scales down. So yeah, where we are, I currently. Yeah. Are there any questions?
Thank you very much, Thomas. That's a fantastic walkthrough there. I love Code Engine. Code Engine is fantastic. It really takes the stress away from worrying about the infrastructure and all the underlying technology. It's one of those ones where it's kind of like a plug and play, and it's really good. So thank you very much. That's fantastic. We did actually get one question through Twitch, and they said, "Hi, is your Keycloak instance also deployed to IBM Cloud?"
Yeah, at least the instance itself is deployed to IBM Cloud because it runs on Code Engine. So that to get these questions a little bit more precise, when you want to instantiate a Keycloak professional, not like that example here, then you maybe can do it by your own configurations, or maybe you use that let me say the cloud, not the cloud pack, the operator which is given here also in the Red Hat open Red Hat marketplace. Yeah, can instantiate it from there and deploy it to the Red Hat OpenShift cluster, for example, and use it here. This is only for an example, and you are free to use where you want to use Keycloak. Yeah, and that is. Ich bin mir leider nicht sicher. And that is, and that's, and that is everything what you have to do. Yeah. So, and yeah, I like Keycloak. It is very, very powerful. It is very, very powerful. And what I because that also what I did with the app ID with app ID. So I replaced that with app ID, and this also. But for sure, it is not comparable from that perspective. Yeah, if you want to really easy, very easy of use, and you do not want to configure really in depth a lot of functionality, then it's really great because it is very lightweight and also for free for playing around. That's also good. So hopefully I answered the question.
Yes, I think you did, Thomas. That's brilliant. Thank you. That was the only question that we really got from the audience, and we are actually on the dot of 12 o'clock now. So I believe that is time for our next speaker. Our next speaker is Tim from Viada. I believe I said that correctly. Would you like to come to the stage, Tim? And once again, thank you very much, Thomas. If you have any more questions for Thomas, please reach out on either LinkedIn or you can contact him via Twitter. And all the resources we will get out to you as well. So there'll be a link to the Thomas GitHub and so on.
Yeah, great. And I say thanks and bye.
Thank you very much, Thomas.
Thank you, Thomas.
Okay, then. So next up, we have got Tim, and he's going to be talking to everybody about OpenShift for developers, specifically the built-in DevOps tools. This is going to be another really interesting talk. Miriam, do you have anything else to add?
No, just really happy to have Tim back. Welcome back,
Hello
Tim.
together.
We loved your session before. Yeah, looking forward to this session too. And I'm wearing an OpenShift t-shirt. I thought I'd be on brand.
That's brilliant. Okay, I guess with that being said, we'll turn our cameras off and mics off, and we will hand it over to Tim.
Yeah, thank you. Hello together. Wait a second. I want to share my screen for my presentation. Wait a second. Here, share. Miriam, there's the share button. Wonderful.
You got it? Super.
I got it.
Whenever you want to start the polls, just let me know. I can turn them on and off.
Okay, I will. I will say if the time will comes.
Super. Thank you.
Okay, wait a second. So some last preparations. Okay. Yeah, hello everyone, and welcome to my talk about cloud computing with OpenShift today. First of all, thank you, Miriam, for giving me the chance again to be one of your speakers today. I'm really looking forward to do because today we explore OpenShift from a developer's perspective and try to build our first build pipelines and deploy our built applications later on in an automated way. So today we will about the two newly released technologies of OpenShift. First, the OpenShift pipelines, and second, the OpenShift GitOps operator. Yeah, but before we start, I would like to say something about our company because my boss gave me the time today to be able to hold this talk at all. So yeah, we are Viada. We are an IT company that designs and implements all kinds of individual IT solutions for our customers, especially when it comes to the technology of Red Hat. And yeah, because Red Hat is our partner for developing these enterprise-ready software for our customers. I think you know Red Hat. Red Hat is one of the world's leading provider of open source IT solutions. And yeah, and we have been certified a Red Hat Premium partner since 2006. This year, there was 15 years working together. And yeah, in this 15 years, we have reached the highest partner status, which allows us to guarantee our customers a significant knowledge advantage in these Red Hat technologies. And yeah, we have specialized us on the powerful JBoss middleware and the OpenShift container platform. Yeah, but there's an extensive portfolio, including more solutions, hybrid cloud infrastructures, middleware, agile integration, cloud native application development, and yeah, a bunch of automation technologies. Yeah, we make project support and project realization. We're implementing software, doing proof of concepts for you, design prototypes, at some points we help to integrate your application to the IT, and also doing long-term maintenance. We also do consulting. We are a consulting company with this, we do system architectures, application migrations, and more than just that. We're helping with going live, and every time we want to do our best work for our customers. And yeah, we also do training. That's one reason why I'm here today. We make a lot of trainings with Java basics, things, enterprise trainings, web engineering, and give also introductions into Git, CI/CD, and GitOps. Like today, we do Red Hat SSO trainings, JBoss administration, OpenShift, and much more. Yeah, at least I want to say some things about me. Yeah, my name is Tim Schmidt. Hi together, I'm 24 years old, and I started my IT career with developing secure and mobile systems. And after a few years, I switched to the Linux server administration with Red Hat and RHEL, Red Hat Linux Enterprise. And yeah, from there, I switched to the OpenShift container platform administrations. And after a bunch of time, I have some fun with putting application into containers. And in the moment, I'm exploring the most common DevOps technologies on the market. At least I'm a classic consultant for Red Hat OpenShift. But enough to me and enough for the company. What would we do today? So today is a session about CI/CD, so continuous integration, continuous delivery, a lot about DevOps, how DevOps works, how DevOps is. And especially we are looking for two main technologies. First of all, Tekton and ArgoCD. And all together, we are looking how it works on OpenShift. So in the first half of this talk, we make some theoretical things, and after that, I want to switch to an hands-on workshop with you together. And yeah, I hope today we can build our first pipeline together, or our first Tekton pipeline, and our first GitOps application with ArgoCD. Are there questions till here? Then Miriam, could you please do the first poll? I think the first poll was about, I'm interested in, wait a second.
Yes. So I'll just close the other polls that we have open already. It was so there's not too many polls for everyone to choose from. Yep, I've got your first poll. Shall I read it out?
Yeah. So my first question was, do you using the common DevOps technologies like Jenkins or GitLab CI, Tekton, something like that, in your daily business and in your daily operation? Was the first thing I want to answer you before we continue with the presentation.
Okay, great. And people are starting to vote. There's also a question in the chat. Is there a special installation required to do the workshop?
No, I think not. What you need is an OpenShift cluster. Yeah, you need OpenShift for doing that. At some points, you need some cluster privileges. My goal was to do an installation without any cluster admin permissions, but in some kind, and especially ArgoCD, it's not possible to install it without any cluster permissions. So, but what you need is, you need an OpenShift and an environment, but that will we see later on. I like that three roads for DevOps is our daily business, and honestly, no, that's a little bit sad, but yeah, maybe it's like it is. I will look at the poll, but I will continue for the next slide. But I have a look on this poll. Maybe some more people from these 149 people are looking here. Maybe there are some more people which want to do this poll. Yeah, but let me start. Now, I want to start with a never-ending story of developer and operations. And what we see in most projects and in the most IT companies, there are two major divisions in IT. It's the development and the operation. And what we saw that most of them, just the developer develops the application, do a jar and throw it above to the operations, and in the end there's a lot of struggling. So the applications did not run. There are a lot of problems with running the application over another stages within to production, and the inheritance is often a lot of stress and mistrust between these two fronts. And I think we have to build a bridge and between these two departments, and I think that what DevOps means. So first of all, what is DevOps actually, or what does it mean for me? So for me, it's a term. It's made up of development, obviously, and ops, operations, and combine people and, very important, processes and technologies to ensure that the customers continuously receive high quality products. So for me, DevOps means cooperation and mainly collaboration between these two departments. Yeah, but what I often hear, yeah, we can't do DevOps. We are too conservative for that, or it doesn't fit into our structures, or even other excuses. And that's why I would like to take the time today to clear up a few myths about DevOps. So, first myth: DevOps is only for startups. I think that is wrong. So maybe DevOps has been pioneered by the web scale internet unicorns like Google, Amazon, Netflix, Facebook, and the other unicorn internet companies on this world. But they start with a little company. But even these came at some point in the history they came to the point that bad software releases due to mistrust between development and operation would mean a high risk with catastrophic consequences. Like if Amazon will be down maybe 1 or 2 days, maybe 3 or 4 hours, it would be a huge loss on money or something like that. And I think, but even these companies had made it to transform their architectures, their technical practices, and the culture to create amazing outcomes that we associate with DevOps today. So yeah, I think the myth DevOps is only for startups is wrong at this point. The second myth I want to clear about today is DevOps replaces Agile. I think that is wrong too, because DevOps principles and practices are compatible with Agile or with Agile software development. Also, DevOps is a logical continuation of the Agile journey that started in 2001. And yeah, Agile often serves as an effective enabler of DevOps because it's focused on all the small teams continue delivering high quality code to customers. So yeah, I think DevOps replace Agile, it's wrong. I think both will work together very nicely. The third myth I want to clear today is DevOps meaning eliminating IT operation or no ops. I think that is wrong too, because many misinterpret DevOps as a complete elimination of the operations function. The nature of IT operations work may change, but it remains as important as ever. Because, and that is a very, very important point, the IT operation just collaborates far earlier in the software lifecycle with development, which continues to work with the development, which continues to work with IT operation long after the code has been deployed into production. And yeah, and that is what I mean with we have to build a bridge between developer and operations, with processes, with the culture, and with the most common new DevOps technologies. So I think DevOps is just more than we eliminating IT operation. The fourth myth I want to clear today is DevOps is just infrastructure as code automation. I think that is wrong too, because while many of the DevOps patterns require automation, DevOps also requires culture norms and an architecture that allows to reach the shared goals. So this is just more than just automation. So I think DevOps isn't about automation. Not I think it's a sentence or a set of Christopher Little. He says one time, DevOps isn't about automation, just as astronomy isn't about telescopes. And I think he have a good point with this set. And last but not least, one of my favorite myths: DevOps is only for open source software. I think that is wrong. Although many DevOps success stories take place in organizations using software such as the LAMP stack, Linux, Apache, MySQL, PHP. And yeah, the success has been achieved with applications written in Microsoft Net, COBOL, assembly, as well as SAP and even embedded systems. And even Red Hat is also doing its best to harness the latest and greatest open source DevOps technologies for the enterprise usage, like Tekton and ArgoCD, what we will discover today. So in the end, yeah, DevOps is much more than just technologies. It means cooperation, collaboration, and communication between these two departments. And yeah, if you're interested in the DevOps context or in the DevOps teams, so all what I need know about DevOps I have from these two books, written from Gene Kim and Kevin Beer. It's very great books if you want to learn more about the DevOps and the DevOps culture. Yeah, okay. Next part for DevOps. Are there any questions until here? I think not. Okay, yeah, continuous integration and continuous delivery. One very, very important point for today, because we are looking for two DevOps technologies what will do this continuous integration and the continuous delivery. Maybe I think most of you know what CI/CD means. So CI, we have continuous integration. We want to continuously integrate our changes, our Git or changes in our software in our release, so we can check or commit more frequently in our repositories with a consistency in the integration process. So because the worst case, or what I really hate, are merge conflicts. And if you have a bunch of developer, maybe 3, 4, more than 20 developers, maybe the application often spreads in different ways, and it would be very hard to merge them later on when the release stands before. And yeah, continuous delivery picks up where the continuous integration ends. CD automates the delivery of applications to select infrastructure environments. And yeah, continuous delivery is not the same thing as DevOps, but CD is a key of DevOps, and that will be discovered today. Yeah, what we need, so we need pipelines. Yeah? Pipelines all build, testing, security checks, and releases from our application would be the continuous integration. And yeah, to deploy these applications above our stages would be the continuous delivery part. Well, that was it about continuous integration and delivery, what I say. But what we have to answer, how can we make this happen? And there is a point. Yes, container will fix it. So let's do a little throwback about containers, because I really don't know if anybody knows what containers are. We have 3 common ways to operate our applications. We have the traditional way, maybe the older way. So we have 1 or 2, 3 big physical machines, physical hosts, and all these applications running bare metal on this host operating system and sharing resources. And yeah, there are a bunch of problems which will come with that, which will be I think a virtual way. So if we isolate our systems, we'll solve a lot of these problems we have with the traditional way. And yeah, so in our virtual environment, we have our guest VMs or guest operating systems on a hypervisor, but we have the operation overhead also to manage these kind of VMs. And yeah, and the main idea of containers is that we want to isolate our processes. So we take all our frameworks, our app, all what we need to run our application, and put it in one container. And then we can share the container above a lot of environments. So we have our host minimal OS. It runs mostly bare metal. And yeah, that's the common point between the traditional, virtual, and the container way. So today is all about OpenShift and containers. And yeah, in this point, I want to take some seconds for looking for the container advantages. Now, containers offers a very good portability, so we can run our containers nearly on every environment, which has a container runtime. Developers can more easily and better define the operation conditions of the applications, which will take us a little bit near to the DevOps mindset for the DevOps culture. And yeah, the IT operation can focus on the host and platform operations if the developers do more for the operating conditions of the applications. And the testing of the environments can thus be simplified. And for me, one of the important points, the disputes between the development and the operations are minimized for that. And yeah, building and deploying containers can be easily automated. And we know DevOps is not just automation, but automation is a very important part of DevOps. So at least, okay, now we know, okay, yeah, I want container, we want to do container, we want to put our applications in container, but there are some questions left. So how do we manage the deployment of our containers? So what does the infrastructure look like for really large workloads? who configures these applications, who configures the host, how is the host machine fail-handed, and something like that. And yeah, that on this point, there came another great technology. It's Kubernetes. And I think most of you maybe know what Kubernetes is. Maybe, Miriam, could you please do the second poll? I think in this poll, I want to have asked how many of you have already worked with Kubernetes or OpenShift?
The second poll is live, so
the second poll was a little bit too. Yeah, the second poll. I've missed the second poll three slides ago.
Oh, sorry. The third one is live now too.
Very nice. Yeah, that's a good point. So as we talked about the traditional way and the virtualized way and the container way, I'm interested in how do you run your applications? Do you use classic VMs or container or something like that? Two versus one, yeah. Yeah, very nice. So we have a bunch of people who are running his application on Kubernetes or OpenShift already. The poll does not allow both. I'm sorry. Yeah, I know there are some workloads which you don't want to operate with containers, like routers or DNS or other protocols or other important servers, NTP. That's a classic workloads you really don't want to containerize and running on classic VMs. But yeah, I know in the most common ways you have both. You have VMs and Kubernetes or containers in such a container infrastructure. But as I see, the most of them using Kubernetes or OpenShift already. I'm very happy of it. So we can continue with the Kubernetes thing. It's maybe 4 or 5 slides. It's not very much. So in the point, what is Kubernetes? So Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitate both declarative configurations and automations. So in short, Kubernetes is a tool for the container orchestration above more than 1 or 2 nodes. Maybe more than 5 or 6 nodes normally. Yeah, the code short to the history of Kubernetes. Yeah, it was originally designed by Google, and it's now maintained by the Cloud Native Computing Foundation. It's written in Go. Go, it's a very important language for these container infrastructure. And yeah, the first release of Kubernetes was in July 21 in year 2015. It's 6 years ago, so it's not that much time. In February 2006, the Helm package manager was released as one of the important package manager for deploying deploying our applications both more than one cluster. And yeah, on March the 6th in year 2018, the Kubernetes project, and that is very, very, the project reached the 9th place in Git commits at GitHub and the 2nd place in authors and issues after the Linux kernel. So Kubernetes is one of the, after Linux, the 2nd big open source project on this world. And I think that is very, very impressive for technology that's maybe 6 years old. Yeah, short introduction about the architecture of Kubernetes. So we have in regular we have 3 or more masters which will orchestrate our cluster. They have the single point of truth. It's our etcd, and the masters will orchestrate the workloads on the different worker. So on the worker most we have a proxy, and we have a container runtime of our worker, and the master or the lead master or the scheduler will the scheduler do the scheduling on the different worker nodes. I'm missing the English word. But yeah, that's it's a simple way to explain the Kubernetes architecture, but that is one of the basics you maybe have to know about Kubernetes in a high availability environment. And yeah, so we have a lot of different things in Kubernetes. So yeah, in the center of all, there's our container. So we have our application in our container, and then we will, our container do in a pod. That's the smallest manifest in such a Kubernetes environment. And yeah, then if you have some configs or secrets or some storage, we can mount them about config maps, secrets, and PVCs. We have some services and deployments, and all that we can implement in a declarative way. Sorry for that. So if we want to deploy our container, or if we want to deploy our image on such a Kubernetes cluster, we need to implement kind of Kubernetes manifests with YAML. YAML, the ain't markup language, or ordinarily yet another markup language. And yeah, we can describe how our pod is working, what is its name, which image do you want to use for that. And yeah, we have services, persistent volume claims, but maybe later it will be a little bit more deeper into it. One important feature that we have to understand before we can go to Tekton and ArgoCD and all the operator stuff are custom resource definitions. So CRDs, or custom resource definitions, give us the ability to extend the Kubernetes API and develop technologies beyond the standard Kubernetes capabilities. So we have like custom Kubernetes manifests from kind my app, or from kind ArgoCD, kind application, kind Tekton pipeline. So we need custom resource definitions to extend the Kubernetes API and running these new technologies. And yeah, these custom resource definitions are managed by so-called operators. These operators are mostly written in Go. And how to deal with these custom resource definition in form of the YAML manifest is then implemented together with the actual logic in these operators. But more about that later. Are there any questions until this point? Okay, yeah, I see most of you running your applications in Kubernetes and OpenShift already, so I think most of you maybe know what Kubernetes is and how it works.
And there is a question on Crowdcast. The question is, what is the difference between Docker and Kubernetes?
The difference between Docker and Kubernetes is Docker is just a container runtime. So if you, this is much more than just a container runtime, but normally if you have installed Docker or Docker Desktop or something like that, you can run your container on this container runtime. Kubernetes is just an orchestrator. So you don't really run your container on Kubernetes. You run your container. Or Kubernetes will orchestrate your container above the different server. And which container runtime is installed on the server, it's another point. Kubernetes is only for the orchestration, not for running your containers. I hope this would answer the question.
That's great, thank you.
Okay, yeah. And if we understand what custom resources are, we can go to the main content of today, Tekton and ArgoCD. So yeah, we just take a look about pipelines and continuous integration and continuous delivery. But now we have the question, how can we make this happen? So for that, there's an open source technology. It's called Tekton. Tekton is a powerful yet flexible Kubernetes native framework for creating reusable CI/CD systems. It started as a Knative build project, and it runs on Kubernetes. And yet the important point, it uses the custom resource definitions to extend Kubernetes. So mainly every single step, not every single step, every single task you will have in your pipeline will run in its own container on OpenShift. So if you have a big a pipeline maybe like that. You have one container who's doing the build, the next container is doing the test. After that, other containers will do security checks and maybe build your application for release them. So what Tekton really do is it's a pipelining tool. It helps us to automate our builds, our checks, our tests. And what I want to say, a very big difference between the traditional CI/CD and the cloud-native CI/CD. Now, the traditional CI/CD is designed for virtual machines, like Jenkins maybe. No, you have scripts, you do your workload, and then deploy your application on virtual machines. The difference to the cloud-native CI/CD is that Tekton is designed for containers on Kubernetes. So a traditional CI/CD requires a lot of IT ops for the CI engine, and on the cloud or in the cloud on Kubernetes or OpenShift, this is like a pipeline as a service. So you have really no ops overhead for building your pipelines. There are a bunch more like the plugins shared across the CI engine at the traditional CI/CD. In the cloud-native CI, all pipelines are fully isolated from each other, so they really do not interact with another or share some resources. That's a very important point. And there are some more points, but after that you can maybe read them. So we have not so much time today, so I want to skip to the next slide. What a very important point, infrastructure as code. So we have to understand what infrastructure as code is for understanding what ArgoCD after Tekton does. So with infrastructure as code, the infrastructure is managed and provisioned by code and not by a manual process. Maybe a few years ago, you have a web server, you build it locally, and then you go to your virtual machine, apt install or yum install, HTTP, Apache, systemctl enable, start, put your applications with FTP to the server. That was infrastructure as code today means. So an important component of infrastructure as code is that it is versioned and controlled in Git. So we take our code for infrastructure deployments and do the same version control as we do with our source code. And like any other software source code file, your configuration files be subjected to the source control. And through automation in infrastructure provisioning, servers, operating systems, storage, and all of these components don't have to be manually provisioned and managed by developers every time they develop or deploy an application. That's a big advantage to how it was a few years or maybe 10 or 20 years ago. And then we come to the point, what is GitOps? As you know, infrastructure as code, okay, now we have all our code, what we need to deploy our infrastructure. We use GitOps to roll them out. So all application definitions, configurations, and environments should be declarative and versioned. And the application deployment and lifecycle management should be automated, auditable, and easily too. So what we used to do is Git is our single source of truth for our deployment. Everything what we need for our deployment is treated in code, and all the operation workflows going through Git. And if we understand that, what GitOps is, we can understand too what ArgoCD does. So what is ArgoCD? ArgoCD is a declarative GitOps tool built to deploy applications on Kubernetes. So it will monitor our Kubernetes, detect drifts in our application deployment, take an action, maybe deploy a secret which was deleted, and then we'll sync the Git repository, so our infrastructure as code, with our Kubernetes cluster. And you can have a granular control over the sync or other complex rollouts, and you can do rollbacks, roll forward to any Git commit you want. And you have manifest templating support, like Helm, Customize, and a bunch of more. And ArgoCD have a very good visualization, but later on we will see it. And how is the workflow we also want to implement today? So the first step is that we have our source code. We have our developer and our source code, and we will check it in our first Git repository. It's on the. I will wait a second. Okay, yeah, now it's better. So we have our source code repository. If any developer will check in his code, a webhook will say to Tekton, hey, here's a new commit. Can we please build this application? And then Tekton runs, fetch the repository, package our Maven or other applications, build an image, deploy it in our SID environment, then push our image to our image registry. So SID for our integration tests. Maybe it could be another OpenShift cluster as our prod environment. You can, operate them in AWS, in the IBM cloud, as in your rack, if you want. And after Tekton is ready and has run to the end, it will automatically update our infrastructure as code resources, which will here in a second Git repository. So we have two different Git repositories, and ArgoCD will make a notice of the change here. Oh, hey, the deployment has another base or has another image. Okay, wait a second, I roll out them. And then ArgoCD will roll out it on the UAT environment automatically if you want, and then manually to the production environment, because full automated deployment to production is a very high risk. So ArgoCD gives us the option to do that manually. Are there questions still here?
Yes, there was a follow-up question to the previous one. Just a clarification. So is Kubernetes for cluster management and Docker is for container runtimes?
Yes, it's really that is it.
Super. Thank you. Thanks for clarifying.
Okay, then let's go ahead. And what we do today, we will rebuild this today with a real pipeline and a real ArgoCD. So what we do, we plan what we want to code, we code what we want to code, check it in our Git, build a container, test it in the cloud, release it in our GitOps source repository, deploy it in production or maybe in some other stages, operate them in the cloud, monitor them, and then go back to the developers where we want to plan together what we can do better in the next release. And that is this infinite DevOps loop. Maybe the most of you maybe know these DevOps loop. And for today, maybe as we know which technologies are behind them. So we code with Java today. Today we do a Spring Boot application. You need Maven to build your Java application. With Builder, we will build our containers. With Tekton, with the pipeline, we will test it, build it, check it in our GitOps repository, deploy it with ArgoCD, operate it on OpenShift. Then you can monitor it with some other technologies which are not the focus today. And then the whole loop will begin from beginning. Okay, last very important point. What is OpenShift? So I want to clarify the difference between Kubernetes and OpenShift. OpenShift is an enterprise Kubernetes distribution. It's a very important point. So OpenShift's engine is Kubernetes. So most of the workloads you have implemented for Kubernetes will run on OpenShift. But what is mostly the problem with creating a Kubernetes cluster? So I want to install Kubernetes. Okay, then you have some other things you have to answer. So which operating system you want to use? Then which container runtime you want to use? Do you want to use Docker, Podnum, Containerd, CRI-O? Which container runtime will Kubernetes operate together? So you need maybe you will need a container image registry if you want to professional do your work and deploy your applications in the cloud. You need on Kubernetes, you need a bunch of proxies or reverse proxies like the ingress router. You need storage. You need storage for running containers if you have containers with storage. You need monitoring, logging, DevOps. The console would be nice, templating, security. What I want to say, one does not simply install Kubernetes. So from zero to hero on Kubernetes, it's a very long way. And I would say I really don't want to be the guy who has to operate an productive Kubernetes environment, because it's such a big cloud of different technologies. And yeah, there will come Red Hat, and Red Hat will do that for us. So OpenShift is a container application platform product for the cloud computing developed by Red Hat. So it's a Kubernetes distribution which do all these stuff which we have to do if we want to do it manually. Yeah, so OpenShift container provides the Kubernetes environment, and in addition, it offers enterprise-ready monitoring solutions, a logging stack, DevOps technologies, and much, much more. So in short, say, Kubernetes versus OpenShift, it's a project versus a product. That's the main difference between Kubernetes and OpenShift. So if we take a look about OpenShift, you will see, we have as in Kubernetes, you need maybe physical machines or virtual environment, private or public cloud, like Azure, IBM, Red Hat. Many providers have a cloud for that. And what Red Hat for us do with OpenShift, we got a Red Hat Enterprise Linux or RHEL Core OS, so we don't have to choose one of the host operation systems. We don't have to choose them. They will deliver Kubernetes for us and fully supported automation, ops, monitoring, registry, networking, router, Helm. All what you need is in the OpenShift Kubernetes engine. Is there. And OpenShift, and then comes the OpenShift container platform. We have such technologies about service meshes, CI/CD pipelines, full stack logging. We have database subscriptions, integration, business automations, code-ready workspaces. There's so many features you have with the OpenShift container platform. And in the end, you have an advanced cluster manager. So if you have more than just one Kubernetes cluster you have to handle, the multi-cluster manager is a very nice way to go. Yeah, but in the end, it's nearly the same as Kubernetes. We have our master or control planes which control the cluster. We have our developers and our operations which will do API calls against them, and then our workers which will do the workload for us. Okay, then I would say let's start. From Git to mid to production. So what would you do it in the next 1.5 an hour? We want to build, test, and release our application and deploy it to stage and prod. And what we use for that an OpenShift builds with Builder, OpenShift pipelines, the enterprise distribution of Tekton, and OpenShift GitOps such as ArgoCD. And what we do, what we already said, we have two repositories. We have our source code repository and our config Git repository. Our OpenShift pipelines will do the whole build stuff, push it in the result in the container image registry, and then the OpenShift GitOps operator will roll out the container to Kubernetes. There's a question: what exactly is an optimized CI/CD pipeline? Wait a second. Here, do you read them? The optimized? Delivery. What do you mean with optimized? I will look in a few minutes again on the chat. So I would say let's this party started. Are there some questions until here?
Yes. So there is. Sorry, you saw the question. What exactly is an optimized CI/CD pipeline? Is that what you just answered?
No, I do not exactly understand what the question means. So what he means with optimized CI/CD pipeline.
Ravi, can you clarify what you mean, or can you explain the question a little more? And a question from Roshana. Where is the testing taking place? And it was referring to a slide, perhaps a previous slide.
Yeah. So that is a simple, very simple image of a pipeline. Pipelines can be more complex, small complex. less complex or more complex, and you can do in your pipeline what you want. But maybe you often do the build and the test, and maybe build a snapshot image. And if you reach a point where you said, okay, now we can do to the release, then you take the security tests, maybe load tests. You can do what you want, but I would say the tests come before deploying on stage or prod. And after the build. But where you want to test your applications, it's kind of.
Okay. Thank you.
There's another question. Test automation is using ArgoCD. No, the test automation running in the Tekton pipeline. ArgoCD is only for delivering our containers. All what we have to do before the testing, the building, all of that we have to do with Tekton or with our pipeline, in our pipeline, before we release the images.
Thank you.
Okay. Yeah, I see in this, maybe here, here the testing is missing. It's not the best kind of yeah, I know what you mean with where the testing. So maybe here the point testing is missing. Okay. Yeah, then I have to say, let's do our hands on. So what I prepared for you for today, I will post them in the chat. I have done five important repos for today, which we will use today for doing for building our pipelines. So we have our IBM Festival app development. That is our source code repository. It contains a very simple Spring Boot application, so nothing special. Which we want to build and deploy above more than one stage. We have our Festival app deployment. In this repository are this is our GitOps repository with our resources for how to deploy our containers on the OpenShift environment or on the Kubernetes environment. In this case, OpenShift. So these both are the most important for today. What I actually do, I have two more repositories built for you. One is ArgoCD GitOps. It will have an example how you can easily deploy and run an ArgoCD from scratch in your cluster. We will do it later on. And we have our Tekton pipelines. In this repo, you will find the two pipelines we will build today and one of the tasks I have implemented for today. And last but not least, I have built a customer build image for our pipeline. You can find an example for that. It's just a Docker file which contains, which builds on the UBI and contains Git and a bunch of binaries we need today for building our applications and testing our applications. Okay, so yeah, we do it. I want to do it simple today. So it's not an very advanced pipelining set today. I want to start with a small little example. So yeah, if you have discovered the repository, I would say let's start with OpenShift. So what I have prepared for you, or what I have prepared in our OpenShift clusters, I have a bunch of 5 namespaces created, such as our namespace for our build pipelines. In this namespace, we will run our build pipelines, create our build pipelines. Oh, wait a second. I wanted to do a developer perspective today. And yeah, we have our Java build pipeline. I have a namespace prepared for your own ArgoCD instance, so we can roll out later on our ArgoCD instance. And I have 3 namespaces to simulate different stages like test, integration, and productive. So in most cases, you have different OpenShift clusters for that, but I think it would be a little bit complex for 1.5 hours today. So we will stage with namespaces on one cluster today. So one thing what is very important to do before we can start is you have to ask a cluster administrator if he can install these 2 operators for us. As we as we talked about on the slides, the operators will handle all the custom resource definitions we want to deploy. If you maybe look at the ArgoCD GitOps example, and in the example ArgoCD server, you will see it's kind ArgoCD. And yeah, we need an operator who can handle this custom resource definitions, custom resource, and deploy them for us on the cluster. So that is one very preparation you have to do. You need the Red Hat OpenShift GitOps operator and the Red Hat OpenShift pipelines. And maybe the best way is you have OpenShift 4.8. That is a version which fully support the newest GitOps images and OpenShift pipelines. Is there a virtual OpenShift cluster we can connect? No, I'm sorry. Today I don't have a cluster prepared for doing that. But if you're interested in using a cluster or want to have a cluster, there are OpenShift online courses. You can order OpenShift for maybe in about an hour or a little bit more. And if you maybe later be interested in, you can ask Miriam. Maybe Miriam can help you to deploy an OpenShift cluster in the IBM cloud, or maybe do a connection to the guys who can do it for you. So for answering this question, no, I'm sorry, I don't have a virtual OpenShift for today for you. So I'm working on a cluster which is running on premise, so it's not reachable from outside, from the internet. So okay, yeah, then I would say let's start with our build pipelines. So as you can see on the left, after your cluster administrator installed the OpenShift operators, you have a point that is named pipelines, and you can use Gesundheit.
Oh, sorry, I didn't realize my microphone was still on.
It's okay. So what I want to do today, so it will be a simple pipeline. But what I want to do is to use the onboard tasks we have on OpenShift already. So there's something it's called cluster tasks, which you can use for building our applications or for building our pipelines. So in the beginning, we have our source code repository. Here it's where is it? IBM Festival Development. You can see it's just your source code repository, your Maven things you need, your POM XML. All you need to run you build your application and the Docker file for the container later. So the first step, what we have to do, we have to clone our Git repository. So we can just select this task git clone. It's one of the cluster tasks which is provided with the OpenShift pipelines, and then we have to fill in some parameters. So first of all, we need the URL repository to clone. Okay, then let's take the link. Let's do it like here. At the .git. I really don't know if you really need them, but it's better you have them. The revision you want to use if you have more than one branch. In our simple example, I have only the main branches. And you have some more parameters you can give, but no from them we need to use today. So it's okay if we have our URL and our main and our revision. But what we need, I forgot it. We need a workspace. So as you know, that the task can, in every task is one container. So if you want that a container can talk to another container, we need some storage for connecting these tasks. So what we have to do is we have to add a workspace. And I would say source code repo. So we need our workspace source code repo. That is the place where our source code will be for the time the pipeline is running. So we have an output, the source code repo. You can do if you have private repository or something like that. You have to use the SSH directory or basic auth. So you have to provide a secret with these credentials. Today I have all repos are public, so we haven't to do that. So I would say simple Java pipeline. And yeah, then let's test our first step. So you see, we have now a pipeline with only one step, git clone. And now we can start this pipeline. But what we have to do, we have to provide a persistent volume claim with some storage. I already prepared it in this namespace for us, so I can use one existing persistent volume claim. So, okay, and then the first thing will be start. And yeah, let's take a look. Okay, we have a clone. Okay, nice. So first step done, we have cloned our Git repository. So what would be the next step? The next step after cloning is, yeah, we want to build our Maven, our Spring Boot application. Oh, wait a second, it was the final task. Okay, you can put before or after or do it in parallel, but parallel in this case make no sense. So we add a new task and, oh, wait a second. Where is it? We have a cluster task which is called Maven. Is this Jip Maven? Ah, here is it. Maven. Okay. And same thing at the clone. We need to provide some parameters for our Maven build. We can here we have to define our goals. What we want to do. It's like Maven package on the command line. And then you can provide a lot more parameters like the Maven mirror URL, server, proxy. We really do not need them today. But what we have to provide is the code repository which we have cloned. So Maven wants to know on which sources I have to build my thing. So we can do it here. See, no errors. Can save. I would say start, but what you can do, you can start last run. So you will use the same persistent volume claims as you declared before. And then we can take a look for our pipeline. Okay, git clone has worked. Next step is Maven. And then your application will package. I think it would be a couple of moments, maybe a minute or something like that. So we can just take the look here. You see, okay, the pipeline pipeline is running. In this moment, I would say, okay, before we take a look, we can do the next task for our pipeline. So what comes after we have cloned our Git application, or after we have cloned our source code, build it with Maven? Yeah. We have to put it in a container. So there's a builder image for building our Docker files into container. And what you have to provide is the destination image, what you want to use. I have prepared some repos at Quoi for us today. I will paste it in a link. So we have the builder image, the app release, so our custom builder repository, app release repository, and our snapshot repository. And what I want to use is the snapshot repository after the first build of our first snapshot. So I will paste the URL for our registry here. So now he knows where he have to push the image if he is ready with working. So, you need the builder image that would be set with the task. You have to provide a storage provider where the builder task can find the Docker file. And as you remember, we have cloned our source repo in our workspace. So our workspace is looking like that. And here is the Docker file he needs to build. So if we just say /dockerfile, he will find the Docker file. You can do some more parameters like the context, a little bit of TLS, the format of Docker or the OpenShift container or OCI. build extras. I have to use some push extras because, yeah, I have to provide credentials on the push extras. I will do that 1 second. So first source code repo. Well, now I have to hide my screen for 1 second and have to search for the credentials. Okay. Oh, wait a second. I have to hide. Okay. Yeah. So I have pushed here some credentials that allows Builder to push in my registry. I can't show you because I think it's obviously. So now nothing is read. We can save. Okay, let's take a look. Okay, we can see our last pipeline run have built perfectly. So Maven has finished after yes, in half a minute and has built our application. Very nice. So I would say let's start a new run. But one thing I forgot is that we can see the difference. I would say let's test take 0 run, so that we can see the difference between the latest image I have provided in the repository for you. Wait a second. As the newest feature, you can log in Quoy with your Red Hat credentials. My keyboard isn't working. Okay. Well, okay. So as now we has only the tag latest, and I hope that we after this push have tag 0 run. Okay, let's save the pipeline. I would say start last run. So like the last run with the PVC. And now the OpenShift pipeline is running. Are there questions so far?
Hello.
Hello.
Sorry about leaving my microphone on there. There is
Welcome.
the question from before, what exactly is an optimized CI/CD pipeline? And we have a bit more of an explanation. By optimized, Ravi means containers and microservices have increased the speed at which software is put into production. They've also increased scalability, especially for cloud-native applications. Agile development and CI/CD practices have been instrumental in making these new application modernization methods effective. So is that what an optimized CI/CD pipeline looks like?
I would say so. It's more than just an optimized pipeline. I think it's a whole bunch of optimization in the back end, in the front end, how you deploy your things. There's a lot of optimization in the cloud native CI/CD environments. So yeah, I think that what he written with the optimized, I mean, these containers and the microservices increased speed. Yeah, I think that could be the answer of this question. That is an optimized CI/CD pipeline. Maybe a fast CI/CD pipeline which help us to build, integrate, and deploy our software fast.
Super. Thank you.
You're welcome. So let's take a look. Okay. Okay, I have not as bad. But if you see, as you can see, we have to wait maybe a second more. It's running. Okay, it's pushing right now and digest it to the result. So we have to wait a minute more. And as you see, I have provided in these in our Git repositories, I have provided these pipelines. So if you go to the pipelines, you can see we are building the simple Maven pipeline. So we have the git clone cluster task, we have the build cluster task, and you can easily also do OC apply on this pipeline. Only thing you have to replace is your CROI user and your CROI password. I really know that's not the common way to provide credentials to a pipeline, but in this case, it was important for me to use the cluster tasks. You can also implement own tasks. I would prefer to implement own tasks for doing these workloads, but it was important for me to show how fast you can click and collect a pipeline on OpenShift. So you can see all these 3 steps has finished. So if you see here, there is tag 0 deployed. Okay, very nice. Because we have not a lot of time, I would say, I will leave this pipeline here. But what I want to do here, I want to show you. We don't publish because there are credentials in it. So are we in the right project? No. Oh, what's the namespace called? Java build pipeline. Okay, I switched to the project build pipeline, and now you can with OC apply F simple pipeline. In my case, with credentials, I'm using not the pipelines in the Git repository. I just do the infrastructure as code, the GitOps thing, and you see here's a simple Maven pipeline I want to build with you, the simple one. So we have a git clone, Maven build, push build and push snapshot, take some integration tests, and then do the release. And one thing is more different in this pipeline. You have a parameter, because if you don't want to push latest or take one, so you don't have to touch the whole pipeline. So if you run this pipeline, I would start them. I can say, okay, feature 22. It's a tag of our new feature, and yeah, I have to provide the source code space, and then we can start. I will start this pipeline, and in the end, you will see we have both. We have here a new tag with feature 22 in our snapshot repository, also as in our release repository. So, but now I want to build the bridge to ArgoCD. So what other pipeline in this point do not do? Oh, wait a second. We have no workspace for basic auth. Safe. Okay. What our pipeline did not do is to update our GitOps repository. So what we have to do in our next step in our pipeline is, if we have built a new image with new tag, we have to replace the image URL path in our deployment. So that is a very important point we have to do, and I prepared there's something for you. So you will find a custom task, which is called, wait a second. I think I have a patch deployment tasks. Yeah, it's a patch deployment task. You have to deploy them with OC apply in your namespace, and this task will change or will patch the image path we have to do, and then we'll do some tests. If that was successfully, do a git add, commit, and a push in the GitOps repository. So I would say let's deploy this task, that we can use it in our pipeline. wrong folder. So I have now deployed the task in our current namespace. It's this namespace. And if we now want to create a new pipeline, you will see here between all the cluster tasks, there's a little task main patch deployment. And in the patch deployment, we have to provide our GitOps host name, like GitHub, the repo path, the builder image, the branch, the stage, and the image URL we want to fix. So the second pipeline, which we can, because the time not built together, is the simple pipeline with push. So I will apply it for you, and will do run. Okay. So you see, I have deployed the second pipeline in our environment. And if we go back to our pipelines, you will see, oh, here's a simple pipeline with push. And that is a little bit more, so it's not very parallelized. So there are not many, there are no security checks, no scannings, no code analyzation. You can do and extend the pipeline as you want, but we do a clone, a build a snapshot, then clone our GitOps repo, patch test our test environment, so the image URL in our test environment, do integration tests, build our release, patch integration, and in the end, patch prod. I forgot to name it patch. Okay. So what now I want to do, first of all, so we have our latest image. So I want to deploy ArgoCD in the next step to roll out our new images, our new tags, and to roll out our Kubernetes manifests on the cluster, like this. So I want to deploy our deployment, the horizontal pod autoscaler, root scale, and all of that. So first of all, we have to do is we need to deploy in ArgoCD. I've prepared it for using it. So I have prepared the namespace, which is called Festival or IBM Festival on ArgoCD. And if I take a look at an administrator to this namespace, you will see there's nearly nothing deployed in this namespace. So now I will deploy our ArgoCD, and we easily can do it with OC apply K for customize, and then he will roll out all we need for running our ArgoCD. What it is, it's just our ArgoCD server. So that is our server with all the YAMLs we need. One thing, and that is a little bit sad, you need a cluster admin who can roll out you a group which you need to use later on, that your account. So my name is Schmidt in this cluster, and I'm a member of the group own GitOps admin group. And only while I in this group, I have ArgoCD cluster admin permissions to use the ArgoCD instance later. So that is one thing you have to do before you can roll out this cluster. And one second thing, ArgoCD, as in the vanilla version, ArgoCD needs cluster reader permissions. So ArgoCD wants to read every Kubernetes resource in the cluster, and only a cluster admin can roll out this cluster role and this cluster role binding. So before you start with rollout, you have friendly to ask a cluster admin if he can roll out the group and the cluster airbag. Okay, but I think in this time, I have deployed it in the wrong namespace. Okay. Now I can apply. Okay, so what we have done. So you see, we have now 5 deployments and pods will come up. You can use the OpenShift GitOps operator to instantiate ArgoCD. So you can do it from the command line if you have the prepared YAML manifests, but you also can create an ArgoCD from the GUI. So you have to, not every time, but you can do a lot of options which you can use to operate ArgoCD if you want to, but you can also use the YAML format for doing that. What we now roll out is a new ArgoCD instance, an app project, and a bunch of applications I want to show you. So let's take a look. Maybe ArgoCD is already ready. Nice. One thing, ArgoCD don't like to use the wildcard certificate from the cluster. So ArgoCD wants an own certificate. So if you want to provide, or if you want to operate ArgoCD on an enterprise level, you have to replace their snake oil certificate. And as you can see, ArgoCD will connect to the OpenShift SSO. So you can easily use the OpenShift SSO for authenticate in ArgoCD. And as you see I'm in a group of the own GitOps admin group. So my user has admin permissions in this ArgoCD instance. So only thing you have to do after you have deployed this, you see, okay, we have here our 3 applications, our Java app in test, int, and in the production stage. What you can see is namespace is not managed. So one last thing you have to do before you can run these applications after you roll out these manifests, you have to go to your cluster settings and add these namespaces to the managed namespaces. After that, ArgoCD can deploy your source code in the destination namespaces. And you have to wait a few seconds for checking if this was successfully. Okay, yeah, it was successfully, so all the changes were good. So we can go back to our ArgoCD instance, and you can see, wait, I go back to test. So, and as you can see, we have only to refresh our app, and now it's working. And what ArgoCD does is it goes to our deployment, so to our repository here, which is used with the templating customize. It uses the test patches and will deploy our application in our destination namespace. You can do all these parameters, set these parameters in the settings, and you will see. So we have here also our image latest. Maybe our pipeline is not ready, is not running. We have to start them. Wait a second. But you can see here, this is a namespace who is managed by ArgoCD. So if I now look back to the ArgoCD, to OpenShift, and go in our test namespace, trust me, which was empty, you can see here in the workloads that there are 2 new pods deployed 1 minute ago. The deployment deployed 1 minute ago from ArgoCD. And now if we go on this route, you can see, greetings from Spring Boot. So you can see we have deployed our application over ArgoCD. Yeah, and that we can do with all our repositories, such as test, prod, and integration. So in this moment, they are degraded because the horizontal pod autoscaler has not received the important RP code from the application. So it will be degraded maybe 1 or 2 minutes longer. So okay, so we have rolled out our ArgoCD. Now let's take a look to our pipeline, to our bigger pipeline, I would say. Okay, so we have pushed with a new tag. Maybe let's take a look. No, we do not. We don't have run this. So okay. Same as in the other pipelines. So we have to provide our image tag. I would say feature 22. Say we need our source code persistent volume claim for our source code. We need a last persistent volume claim for the GitOps space, and we have to provide our Git credentials. I prepared it before, so you need your Git credentials that the pipeline can push in your Git repositories. So now we can start. And that may take his time. One last thing I want to change before we start, maybe. So that is the last action before we run our last do our last pipeline run or our last run, and then we have I will give you the chance to do or to take some questions. Okay, in our app development, I want to change our hello, greetings from Screen Boot. Okay. I've done some new cool features. So let's check it in. One second, I forgot to do that. Okay, so I think we have pushed our new Git or our new application stand, our new feature. We have pushed them in the main branch. I'm sorry for that. But as you can see, 27 seconds ago, we have probably added our source code repository, and now we can start our pipeline. Start cool new feature source code repository and our Git credentials. Okay, so maybe this pipeline needs 5 to 6 minutes, I guess, to work properly. So I think we can start with some questions and answers. Okay, there's one question left. Can you use QuiO to create OC clusters? No, you can't. Yeah, you can't use Qui as a mirror registry if you have some restricted network things. So you can use it as a mirror for instantiate an OpenShift cluster, but you cannot use Qui to create OC clusters.
And that was the only question we got so far. So thank you for answering that. I'm just checking across our other platforms we're streaming to.
Okay. As you can see here, feature 22 of our last one was already released in our snapshot repository. And now all our applications are healthy. So if we go above the different state, oh, we have a fail in our Maven build. Maybe I've got okay. Maven don't like apostrophe. Yeah, and that is a good point. So if you see that you check in trash in your source code repository, the pipeline will instantly fail. So that's a good point for improving your code. Let's take a look on prod. So that is now our prod stage, and as you can see, is already greetings from Spring Boot. And I think after the last run of our build pipeline, there will be more than this, but that's take a little bit time. Miriam, do you have some questions left?
So I did ask some of the questions. We have got one more poll for our audience, our live audience. The last question is, have you ever worked with Tekton or ArgoCD? And so far, all the votes are on no. So this seems to be quite a lot of new technology for our audience today.
I think so, yeah. So Tekton and ArgoCD are really new technologies. So the operator maybe 1 or 2 years old for OpenShift, but the release of the first supported GitOps operator and OpenShift pipelines is maybe 4 or 5 weeks ago. So
Wow.
that is it's a very new technology. Okay, yeah, we can see there's more fail more. Okay, maybe it would not in this call. You can see that we can roll out easily our changes on the production stage. So sad. But yeah, so if you wanted to reproduce it, feel free. I will improve the repository in the next couple of days, maybe in the next couple of weeks. So take a look on the repos. I will improve the deployments, maybe do a little bit fancier pipelines and maybe a little bit more and better introductions how to deploy the Tekton pipelines, how to deploy the ArgoCD, so that you can use this manifests to reproduce it on your own clusters.
Sounds great. Thank you so much.
You're welcome.
Yeah, amazing. And that it's such new technology as well. This is cutting edge.
Yeah, so yeah, it's a very new technology. I really love them. We have rolled out them in a bunch of customers, which are also big player on the German market, like banks or other companies. So yeah, it's two very cool new technologies, and I hope that I can give you a little deep dive in how to handle these technologies on OpenShift. If you have
Awesome.
any questions, anything after, maybe tomorrow, next week, feel free to contact me. Feel free to contact our company, or feel free to contact Miriam for asking. Then Miriam knows my email address. And yeah, so if there's nothing left, I would say thank you for your audience.
Yes, thank you so much for your session. Love the hands-on and really like a great session. And thank you for answering all the questions from the audience too. There's applause in the chat. That's awesome. Yeah, and I hope we can welcome you again to one of our online events soon.
Sure.
It'd be great to have you back, Tim. Always a pleasure.
Sure, you're welcome. Thank you very much.
Thanks. Have a great day.
Have a great day together. See you soon.
Bye.
Bye.
Great. So thanks so much for tuning in. If you're joining us, we've just reached halfway through our program for today. And we've got 2 more sessions coming up. So we've got the next session is how to deploy applications on Red Hat OpenShift. Just going to invite Asna and Masa to the stage. And they'll be joining us. Thanks for all your comments in the chat, really appreciate it. Great session from Tim. So while they're joining, if you're new to Crowdcast, you can click the green follow button in the top right of your screen and follow us for all our talks and hands-on workshops. Thanks for joining us, Roshana. Thanks for all your questions as well. Have a good night. Oh, in Australia, that's a big time difference from here in Europe. Glad you enjoyed the festival. Look forward to seeing you again soon. And yes, if you're joining us on Crowdcast, you can chat with us here in the bottom right-hand corner where it says say something nice. You can also ask us a question for the speakers related to their talks or workshops. And on the green button, you can sign up or sign in to IBM Cloud. So I see Masa is on screen and Asna is connecting. Okay, just 1 second, switching browsers, that's no problem. If you are joining us today for the first time in our developer festival, then I'd like to share with you a link to our feedback form, and in the feedback form you can, in as little as 3 clicks, you can share with us what you thought about the sessions today, yesterday, or on Monday too. So we'd love to hear what you think. I'm going to post that link in the chat. You can tell us, yeah, what your thoughts are and suggestions for future workshops and talks, or how we can improve. We'd love to hear from you. And if you missed our sessions on Monday, we had a real wide variety of sessions, from quantum to infrastructure to machine learning with chatbots. And on yesterday, we had open source and artificial intelligence and machine learning sessions. So a wide variety of topics. And we also have a new series starting, which runs every other Tuesday. It's called Accelerate Your Data, AI and Automation Journey. This is from a team here in IBM Developer Europe, and they've got it set up so you can join every other week and learn more about machine learning, data and AI and automation. So if you fancy joining that, I've also put the link to that in the chat. And for today, this is the schedule. All the sessions are being recorded, so if you want to watch it again, as soon as the live stream has finished, you can hit the refresh button and watch it again. So I've sent a new invite. I hope that works. Okay. Massa, can you hear me? Is your microphone working all right?
Hi, I can hear you. Can you hear me?
Super. Hi, yes. I was just worried my headphones had stopped working. It got very quiet. Great. I'm just going to send Asman another invite. Okay, super. Looks like it worked this time.
Hi, Miriam. Can you hear me?
Yes, hello. Welcome both of you to the Developer Festival. We're really looking forward to your session on how to deploy applications on Red Hat OpenShift. I got my OpenShift t-shirt on.
Awesome. We are super excited. Sorry for this little inconvenience. Happens in live sessions, so I think that's okay. So I'm gonna start sharing my screen now. I am super excited for today's session, just like all of you. Do let me know if you guys can see my screen.
Yes, we can see your screen.
Awesome, we are good. Hello everyone, my name is Asna Javed. I am a lead developer advocate from Pakistan. Today I have Masa Abushamle with me. She is a developer advocate from Dubai. She is a Red Hat OpenShift expert. And we are going to conduct a workshop today about how you can use universal base image to deploy applications on Red Hat OpenShift. So for those of you who are wondering who is speaking, I am not turning on my camera because I am having some network issues. So I don't want to, make an unpleasant experience for you all. So that's why no camera for today's workshop. But we are going to have so much fun today. And do what we're going to do today is we're going to talk about what is container image. I'm pretty sure that you guys are already familiar with these concepts. But in case you're new to this, we will be talking about what is a container image. We'll be talking about different concerns that are related to container images. Then we'll be talking about Red Hat UBI. And then moving further, we'll be talking about what is a UAI. There are 3 different base images that we will be discussing and covering today. We will be also talking about the pre-built language runtimes. And lastly, we'll be talking about the best practices for designing a universal application image. And then the hands-on would be there. And Masa is going to conduct the hands-on for you all. Do follow us along. Let us know in the chat whatever your questions are, your concerns are. We would love to hear from you all. Before we can start with our presentation, you would have to create an IBM Cloud account. This is the link. You can Masa is going to share the link with you guys in the chat as well. We also have a tutorial link that you can follow us along. Also, for this workshop, you would need an OpenShift cluster. So for those of you who are new and haven't used a cluster yet, you would have to go to this URL, that is ibm.biz/devfest clusters, and the key for your cluster would be OS Lab. So to achieve your cluster, you need to create an IBM Cloud account. So for those of you who don't have the IBM Cloud account yet, please feel free to click on this link and create your account so that you can follow us along in the workshop. And by the way, we're going to take it very slow so that you guys can follow along and have a more interactive and fun session. All right, so let's jump into what is a container image, right? In the most basic definition for container image is like it's a static file which is which has like these executable codes, that you can create a container on a computing system. So basically, container images can include everything a container needs to run on, which includes Docker or maybe a core operating system, some system libraries. It also has some utilities, some of the configuration settings. It also has specific workloads, that you would need to run the container, and so on and so forth. So it is immutable. meaning it cannot be changed and can be deployed consistently in any environment, right? So here is a diagram that shows you what a container image can, look like. So basically you would have some container layers, some image layers, some base images, kernel, read only, and write only. So these are like some of the like a basic diagram or a basic layout of a container image. So let's move further. Also, just I want to mention here, that as I said, that these are the layers that a container image is composed of. So these are like basically added on to a parent image, right? Which is like, this is a parent image called the base image. Okay, and it is possible to reuse these components and configure them across different images. So constructing layers in an optimal manner can actually help a lot to reduce container size and improve the performance of your overall application and your image. So that's there. If you guys have any questions so far about container images, feel free to ask them in the chat. All right, let's move further. Let's talk about what could be some of the concerns for the contents of container images, right? So the first and the most like the common concern is provenance, right? So basically, we think about like the source of the bits of the container images, where they're coming from, and how the bits are actually organized, right, and how they are like intended to be. So that's provenance. Then we talk about the authenticity. We are not sure if the container images was is a verified image or not. Maybe something has been modified in that image by someone, right? And maybe there are like some other original resources, right? So that's one of the concerns. Then another concern is security. Obviously, like if we're not sure whether we can verify the code running in the container is free of any known vulnerability. So we need to make sure that there are no vulnerabilities. That could be one of the concerns while we are dealing with container images. And then if the default settings of that particular image are secure or not, and especially when you're using that container image for an enterprise solution. So that is very important. Then we talk about quality and reliability, right? We need to understand like what testing is performed to make sure the code works correctly, and were these tests were performed right and well, right? We need to take a look whether the updates were frequently they were introduced or not. And obviously we need to we need to understand that, right, that can create new vulnerabilities or not. So we have to make sure whether that the quality and the reliability is working. Then we come across the performance of an image, right? So we need to understand, have there been any tests to determine how well the software performs under load or enterprise grade hardware. So if you're using that particular image for developing your enterprise solution, right, you need to understand whether the performance of that particular image is well enough, good enough or not, right? Then we talk about the life cycle. We need to keep in mind about the life cycle of that particular container image, like how long will the software in the container be maintained, right? And then how long will the updates be released to fix the bugs and vulnerabilities. So these are some of the things that we need to keep in mind before using the container images. And then definitely the source code availability, whether you have the access to exact version of the code that was used to produce the container images, or if you don't have that. And then last but obviously not the least is the licensing. Like, is all of the software actually open source with appropriate licenses that are compatible with your users, right? So if you're using an image that is an open source image, you need to make sure whether it has these licenses or not, right? You're not doing some plagiarism, or you're not using someone's image and you don't have the relevant licenses. Maybe it's not open source, and so on and so forth. So these are like some of the concerns that comes across when we are talking about container images, right? So Then we move on to universal base image, right? That is Red Hat universal base image. So um, basically, OIC is like it is defined as a standard for container runtimes, right? The OIC runtime specifications as well as the reference implementation run C or Docker or Containeride or CRIO all incorporate as their containers runtime, right? So OIC basically it contains container based operating system images with runtime languages and packages that are freely redistributed. So why we are using a universal base image? Because we get like it is you can easily redistribute it, it is secure, it is safe, right? And it is also built from portions of Red Hat Enterprise Linux. So if you want to go with a container image, go with a universal base image, right? Also, it can be obtained from um, Red Hat Container Catalog and be built and deployed anywhere. And it is like designed to be foundation of cloud native and web applications. So when you're talking about cloud native applications or web applications, right, use cases that you want to deploy them in containers, it's better to use the universal base image. So far, any questions, guys? Feel free to ask me in the chat. If I'm going very quick, let me know. I can slow down a bit. If there's something that you I couldn't explain properly, again, let me know about that. All right. So let's go to our next slide. Now, the question is what you can do with a UBI, right? That is universal base image. So with and I'm not going to get into too much details here, but this is for your understanding that with a UBI, what you can do is you can build a containerized application. You can push it or to your choice of registry servers, right? You can easily share it with others. You can deploy it on non-Red Hat platforms as well, right? Because it is freely redistributed. And then UBI is basically built on RHL, right? Reliable, secure, and performant platform. Those are the um, basics of a UBI, right? So it is reliable, it is secure, and it can be freely distributed with anything, anywhere. All right. So it doesn't have to be a Red Hat platform for you to use a UBI. All right. Let's move further. Now let's talk about what is an OCI. If you remember, here I mentioned that the OCI complaint container, and let's talk about what is an OCI, right? So OCI basically it stands for the Open Container Initiative, right? It is a vendor neutral organization that creates open industry standards around container formats and runtimes. All right. So as I already mentioned that these runtime specifications, they have like everything for the implementation, like Dockers and Containeride and CRIO, all incorporated runnings are there as their container runtimes, right? Now OCI is also defined as a standard for container images. All right. So the OCI image format specification, right? That is like basically a standard for container images. And any OCI complaint image will run correctly in like any container host that is running any one of the popular container engines, right? Because they are all incorporated on OCI compliant container runtimes. So this is basically a standard for all the container images. Um, and yeah, again, that's what OCI is, right? I hope that makes sense to you all. And I hope I was able to explain you that in detail. So again, if you have any questions, feel free to ask us in the chat. Okay, now the next thing is that let's talk about what is a UAI, right? Universal Application Image. So we're talking about OCI, Open Container Initiative, and then we have a Universal Application Image, right? It is basically a container image that is built from Red Hat Universal Base Image. So uh, it is obviously OCI compliant, right? And you can redistribute it. It is secure. It has like benefits of both Red Hat OpenShift support, and it can run in OpenShift and anywhere else as well. And then again, it enables your application image to run well in both Kubernetes and OpenShift. So if you don't want to use OpenShift, for example, you can also, run this image on your Kubernetes cluster. All right, and also like it incorporates additional features that is make it, as I said, it makes it more secure, scalable, and again, you can use it in both Kubernetes and on clusters, on OpenShift clusters, sorry. Yeah, so let's get into the details of UBI, right? So UBI has three things. It basically has pre-built language images, it has base images, and then it has RMP package set. So I'm going to discuss all of these one by one with you all, right? So the base images, we have like standard images, minimal, and multi-services. Then we have pre-built language images that are Node.js, so on and so forth. And then we have like Red Hat Enterprise Linux package set in it, right? So let's start with the three base images, all right? As I said, we have like minimal, platform, and multi-services. So when we talk about, let's talk about the platform one. So for any application that runs on RHEL, right? We have like we use the platform image, right? It unifies open SSL crypto stacks, and then it is also full yum stack, and also it includes useful basic operating system tools like tar, gzip, vi, so on and so forth, right? And it is suitable for 80% of typical applications that run on Red Hat OpenShift, Red Hat Enterprise Linux, sorry. And yeah, the image name is UBI, right? So we have UBI 8 or /UBI. So here you guys can see, so it has like yum, and it has, it's basically for the most basic typical kind of applications are used. This is used for to run them, right? All right. If we move further, then we have the minimal image. If you guys have any questions related to the platform image, let me know in the chat. So now we'll move on to the minimal image, right? Minimal image it is named as UBI/minimal. All right, and it is basically designed for applications that contain their own dependencies. Like maybe they have their own dependencies like Python, maybe Node.js, maybe .NET, or any other dependencies that are required, right? So, and then it is designed for applications that as I mentioned, contain their own dependencies, and mostly they are of smaller container images size, right? So it's minimized is basically pre-installed content set, so there's no pseudo binaries here. The minimal package manager is you just install, update, and remove, and that's it. And yeah, I think that's pretty much all for this, right? And if you go to multi-service images, right? So that is UBI-INIT, right? That's its name, right? So it is designed for running multiple processes inside a single container that are managed by system D, right? So let's talk about multi-services, right? So basically, the multi-service image runs on system D. That's what I just told you about. And so, okay, let's take it this way. By design, the containers generally run a single process, right? But when that process exists, right, the container exists itself. So when we want to use like multi-services, right, we have like we are running multiple processes, right? So that's when we use this multi-service image. And so as I said, that they have like their such they have their own processes. So you have like they have their own databases or a web server, and then again they can be run and restarted within a single container. So it eases your running multiple services in a single container. It is as I mentioned already, configured to run system on start, and it allows you to enable these services at build time, right? So that's what multi-service image is. I hope you guys like understand the difference between multi-service, minimal, and our platform images. All right, so let's move further. So we are done with the first step, what the images are. Let's move on to the second thing, that is pre-built language images, right? Now, pre-built language runtime container images are basically, these are the images that, they include languages like Node.js, OpenJDK, Perl, PHP, Python, and much more. So can you guys let me know in the chat what languages do you guys use for your your application building and coding? It would be really fun to see what you guys are using. Do let me know in the chat. All right, so these basically are built on top of UBI platform. It's OS based image, right? And for UBI 8, these runtime images are based on the application streams from Red Hat Enterprise Linux 8. All right. And for UBI 7, these runtime images are, they're based on Red Hat software collection images, and that are available on Red Hat Red Hat Enterprise Linux 7. So RHEL means Red Hat Enterprise Linux. Just letting you guys know. And yeah, you can always go and read more about this. And let's go to our last and but not the least part of UBI, that is our PM package set, right? So it's basically we have associated packages, right? So sometimes when you're building an application, you need to you need some extra packages or a package that needs to be updated, right? So consuming pre-built images is like it's great, like wow, we're consuming pre-built images, right? So the Red Hat it keeps them up to date and releases them when a new version of Red Hat Enterprise Linux is released, and when critical CVs are patched, right? So all right, so yeah, when critical images are patched, so this is what happens, right? So Red Hat, it keeps on updating them. By the way, you can go and check out Red Hat Enterprise Linux image policies as well, to see like how mirroring works, right? And then what happens is that we have like designed this one, so you can just pull one of these images and start building your application. So you don't have to worry about the updates, and you don't have to like really worry about if there are some patches that needs to be added or built or whatever. So Red Hat does that for you, and you can just use them, right? So but sometimes when you're building an application, you need that one extra package, or sometimes you need a package updated to make your application work, right? So that's why UBS also comes with a set of RPMs available via YAM and distributed on a highly available content delivery network, right? So you don't like have to worry about all these things, because well, UBI guys it helps you out. So yeah, so again, as I said, that's when where your UBI comes in. But when you run AM updates in your CI/CD, and you guys just did a CI/CD workshop, at that critical moment, right? Like when you have to do a production release, you are hitting the same infrastructure or like other customers are using, right? So to add some additional software to UBI based container images, right? RPM packages are available in YUM repositories. The RPMs available in UBI are set, they're basically a set of Red Hat Enterprise Linux RPMs. Yeah, Masa, correct me if I am wrong here. So this subset was chosen to basically satisfy common application dependencies, right? And the RPMs, they can be installed with the YUM package management system in the UBI platform, and also the multi-service images. And we just read about that, and I showed you what those are. So if we talk about the minimal UBI image, you use micro DNF instead of YUM. Again, Masa, correct me if I'm wrong. So I'm a bit I was just thinking Yeah, so the UBI RPMs and the repositories basically, they provide a source of packages maintained by Red Hat that you can add to the UBI based container images, right? So here you guys can see, and by the way, this is like really good. And yeah, so they're available. And well, yeah. So okay, and then RPMs available in UBI are the same as their counterparts in Red Hat Enterprise Linux, right? They have the same life cycle and receive the same updates under the normal RHEL life cycle, right? And the advantage of basically using an UBI RPM is knowing that it is if a vulnerability, for example, or a quality issue is found, right? That is fixed by Red Hat Enterprise Linux, right? And then the UBI RPMs also receive the same update, so you don't really have to worry about these things and thinking, oh, might be a vulnerability and this won't work out for me, and but you don't. That's one of the advantages, that it gets fixed by Red Hat Enterprise Linux. So that's there. Let's move further and talk about the best practices for designing a universal application image. And I'm not going to get into details of this because then it would take me hours and hours of explaining this. So I'm just gonna go over and I'm just gonna state that when you're designing a Red Hat, when you're designing a universal application image, right? So you go with non-root arbitrary user IDs, you go with image identification, you need image license, then latest security updates, some group ownership and file permission, and then two-stage image builds are required, and original base images layers are required. And then obviously you need like fewer than 40 image layers, right? So yep, that was it from my side about what is UBI, how it works, different components of UBI. I hope that was like helpful for you, for those who are new to this. If you guys again have any questions, feel free to ask me in the chat. And now we are going to do our hands-on. So for that, let me know in the chat that you guys have created your IBM Cloud account. If not yet, feel free to do that. You would need that, and you would also need to get your cluster of OpenShift to follow us along on the tutorial. So over to you, Masa.
Thank you so much, Asna. Okay, can you see my screen?
Wait, I'll stop sharing. Yep,
Yeah.
we can see your screen.
Awesome. Thank you so much, Asna, for introducing UBI. And I saw in the polls we have some people who have worked with UBI before, which is great. That's really interesting to know. Like people are using it. And in case if you are, this is your first time hearing of it, that's totally fine. We're looking forward to introducing it to you. Today's lab is going to be pretty much simple and straightforward because we're focusing on showcasing the basics of UBI. So we will be doing the, we'll be using the standard UBI image. Now, first thing, before getting with the hands-on, I want to do a quick demo of how you can claim your clusters. You will, one of the links that we have shared with you is like has this UI in front of you. Just make sure to add OS lab and then add your email.
The email that you use to create your IBM Cloud account.
Yes. So make sure that you have already registered, and I believe that most of you probably have already their emails created on IBM Cloud. Next thing is you will receive an invitation on your email. Okay. I'm just letting it load. It might be a bit slow from my side. Just hopefully it won't be as slow for everyone. It depends on the network. Yeah. So you will receive an invitation, and this is why I made sure to just like ask if you could check create your clusters early on. I might have a slow internet connections. This is why it's awesome. So you will get this. And next thing is you're going to need to log into your IBM Cloud account. In case if you do not view it, if you cannot view it, then just really make sure to
Awesome. I see a lot of people are able to access the cluster. Guys, let us know in the chat. Be more active. This is like fun. Let's have fun with this workshop.
Awesome. I'm just logging into my cluster so I could demo it to you guys. Just give me a few seconds and then we can start. Now, till I log in, one of the second link that I want to show you will lead you to the code pattern that we are using today, which is how to deploy a sample currency exchange application on Red Hat OpenShift. So it's just a second. Again, I'm trying to log in. Yeah. Okay. So it is this is like on developer.ibm.com, where you can find any of the open source tutorials, code patterns that you can use for your applications and learn from them. You can also add them to your projects if you want to explore anything. Yeah. I'm going to check again my account. Okay. Just a quick one. Yeah. So it's going to lead you to a GitHub repository, and you will find all of the details of this code pattern. So what's going to do, what are the components of it, and I will be explaining each one of them. Now, I just received the invitation to join the AdvoWork account. It will be like a message, and just make sure to click on join now from your email. This is so you could just leverage your cluster.
Masa, I cannot see your screen. It's not changing.
For this one, because I'm opening my email, and that's why.
Okay, all right. All right, so if you all have access to your cluster, give us a yes or a thumbs up in the chat. We would really love to hear back from you all.
Yeah, so I'm trying to check my email again. Okay, yeah, so you have to accept invitation. It should be here. Like, it will show you here a message. Hopefully that I clicked accept invite right away. So make sure to accept the invitation so you can access your cluster. I know it can be a bit challenging to access it at first, but it's hopefully you won't find it that challenging. Now, once that's done, you will be able to find the AdvoWork account added to you. So we use this account for our workshops, so you can follow along with us. And these clusters, by the way, they're limited. There you go. This is the AdvoWork account. And I should have my cluster ready by now. So it will be available for 24 hours. So you can, feel free to explore it for our own workshop. For the upcoming workshop, we have another one right after this session, and any of the past workshops that involve OpenShift. So yeah, feel free to do that. And if you want to explore it however you like, it's also like, it's for you. Now, click on get the code, so you could access the GitHub repository, which has everything we're going to need, the documentation. And it's a Flask application. So if you are familiar, and I noticed that some of you mentioned that they code with Python, and you might be familiar with Flask and how you can build the Flask applications and the structure of it. Now, I don't usually code with the Flask, but I'm familiar with some parts of it. And you will see here's the architecture. So we're just getting an overview of, like, we're focusing mainly on the components around OpenShift. And it consists of the main application is the Flask application, which uses the Swagger REST API, which will make API calls to the currency exchange API. We can check the currencies between two different currencies like Arab Emirates dirhams and US dollars and so on. And we're using for our application is the we built a Docker file, so we could install everything, the dependencies and the libraries, and run our application in a container. You can run it locally, either using Docker or Podman, however you like, or you can just deploy it on OpenShift. So the API is API layer exchange, and what you're going to need to do is to get your API key. So if you want to make your changes, so I'm going to use an existing image that has already been pre-built, and it already has the API key. But I highly encourage you to try it on your own and see how you can build the image, because you get the look and feel of building your own UBI application from scratch. So for this one, it's using this API, which has so many uses. One of them is like around finance, and you can create a free account and then just to grab your API key right away. And then you're going to have to clone the GitHub repository and then make your changes. You can find, to be honest, so you might not be able to make changes on the main GitHub repository, but you could find, like, for example, I have it on my profile. I forked it from my colleague's GitHub, so you can see the changes. Feel free to check this one out. I know too many links, but yeah. And what you do is, if you go to the source directory and then go to services, so it's going to be the GitHub repository source and then services, scroll down to servicehandler.py. This is where you're going to make your changes. Now, usually this isn't the best practice where you're going to add an access key, but this is just for the sake of demoing. I'm just showing you how you can make changes to this code if you want to play around with it, especially if you are familiar with Python. So just make sure to replace the access key with your own access key. Feel free to do whatever changes you want if you are an expert at Flask, and see how it's going to work. Once that's done, simply just build your application. So one of the components, the main component that we want to focus on, is the Docker file. The Docker file, which you can find in the root directory of this GitHub repository, starts with the base image, which is the UBI. We're going with the standard UBI image, and you can see it's taken from the Red Hat registry. You can choose whichever one you like. So the standard is like the most common, and it's like the easiest, you can say, when it comes to trying to. If you're not sure about which image you want to use, just go with the standard. It's fine. And then because we're running a Python application, we want to install its dependencies. So we wanted to install Python and then install the requirements from the requirements.txt folder. File in the directory. So this is going to be taking the requirements from this repository to build your container. I will show it to you in a bit. So we're copying it into the directory, and then we're just running some Python commands. You can do the same stuff with Node.js for npm, for example, and so on. And then finally, it would just run your Python application using the cmd command. So it's you can notice that it's actually if you have worked with different Docker files before, it's written pretty much the same way. But UBI is like it adds more flexibility and more security when you're working with your UBI image. So as I mentioned just now, we're installing the requirements from the requirements.txt file, which can be found in let's check. Yeah, it can be found in the root directory of this GitHub repository. So if you go there, you will find that we're installing Flask dependencies, anything that we're going to need. So these things, they can differ from different applications, different programming languages. So for example, you would have package.json for Node.js, as I remember, and so on. So, and for this one, it's kind of like it builds the container using this image and the source code that you have. So once you're done, you're going to build and run the image locally, which can be, the steps can be found here. Feel free to make the changes, but I will be skipping them for today, to be honest. I will be just mainly focusing on introducing OpenShift. So the next thing is we're going to use this image here, okay? Which you can find the name of it here, and then we're going to use the tag to build our application. We can use the command line or the web console to build our application. So after we built the image locally, we have to push it to the container registry. It can be Docker Hub or Quay.io, your choice. And then we're just going to deploy it to our cluster, which we will be doing right now. So I am right now in AdWork account. Hopefully everyone is keeping up. Let me know if you have any questions or if you want me to repeat anything. I would be happy to do that. Now, I just like to just recap, a little bit of recap. I was explaining the different components in the GitHub repository, the Docker file, and so on. And now we're going to access our clusters. So to access your cluster, now I showed you earlier how you just simply add, OS Lab and your email, and you're good to go. Just make sure to accept the invitation to be added to AdWork, because you can't be added to it directly. So you will find that you have a resource here, which is in the clusters. So a cluster will be automatically assigned to you. And just click on it. And you will be directed into the overview page. If you are not familiar with what the overview page, it shows you a summary of the situation and the status of your OpenShift cluster. Our cluster has 2 nodes. There's the cluster ID and the version and so on. We can use this information for so many things, especially if you are using it with IBM Cloud CLI. Now there is this blue button at the top right, OpenShift Web Console. We want to access it. So click on that to access your OpenShift cluster. Shouldn't take long to load. Okay, so I'm just waiting for it to load. Do you guys want to see how we can deploy the application using the web console, or do you want to see how we can do it using the CLI, or do you want to use both? Let me know. So we have this. Yeah, go ahead.
Our audience is really quiet today. Guys, let us know in the chat, what would you prefer?
Yeah. So maybe some of you probably already know how we can deploy applications, but I'm happy to showcase both ways for anyone who's interested to try it out. So the easier way, if you are not familiar with the CLI, you could go with the web console. And the CLI is kind of a bit straightforward. Yeah. So when we are going to the web console, you will see that we are in the administrator perspective. Okay, you want to see both ways. Okay, I will do that. So I will create 2 projects. I will start with the web console, and then I'm going, in the end, I will show you how the application will work. So let's deploy 2 applications. So we have the administrator perspective. The administrator is responsible for managing the entire cluster, on a global level, managing the users, workloads, projects, and everything. So they make sure that the cluster and the application and status are healthy. But we want to go to the developer perspective. The developer perspective is what we are going to use to build our applications, and you get to see all of this lists of projects. Of course, do not touch them. These are for the cluster. Anything that has been created, it is to keep your cluster up and healthy. We're going to create a new project. So how do you do that on the web console? If you see there is like project and then 2 dots, all projects, you can go to create a project. So if you click on them, create a project, and I'm going to say, call it my Flask project, not app one. Yeah. So there you go. Now, if we want to do it through the web console, the CLI, it will be a bit different. And if you want, in case if you do not have the CLI, you can use the Cloud Shell. I will share the link with you in the chat. So I can also demonstrate that in a bit if you want to use the command line. Now that we have our cluster up, you will see that this is the add page, and it's you can create your application from different resources. It can be like the catalog, the GitHub repository, whether if you have a Docker file where you want to use inside that inside that Git repository, or your source code. So there are different ways with GitHub, or just search the container registry, or use templates or YAMLs, any way you like. Now, the easiest way is to go with container images. So we want to deploy it from an existing one. So just to recap how you can see it, because it's actually, the UI has changed recently, as you can see. So it was a bit different till now. Yeah, go to the add, sorry. And if you see it here to the right, so we're going to go with the container images option to deploy the existing image. So what's going to do is it will search the image name from an external registry. In our case, we're using Docker Hub. So you can copy the name of this image. I will share it with you in the chat as well. I just highly encourage you to try your own image. But we're going to also need to add the tag. So it's going to be, and then make sure to add the tag in this way. It's going to be, I believe, B0. Yeah, B003. Okay. Of course, you can also change the runtime image icon. You can change the name as well. And then if you keep everything in the default way, so like when you're going to create an application, you can create everything on the web console along with its components, like the service, the route. But you can also choose not to do that. So you can uncheck them. So here we're choosing that we want it to be a deployment. And then we're making sure that we want to create a route to the application. You can also see some advanced options around routing if you want to secure it, for example, or health checks. But I'm not covering that for today. We're just focusing on deploying a simple application. So hit the create. And it will lead you to this beautiful UI showing you that your pod is currently pending. So which means it's in container creating state and it will run. So it actually built real quick, which is really amazing. So if you click on the pod itself, and if you select view logs, you can see, I'll expand it. So you will see that your application is now running. Okay. And yeah, So we want to access it. So here, in case if your application ever fails, you can just go to logs and see whatever the error is going to be. So let's go back to, you can also view the details here of your application. I really highly encourage you to spend more time trying to understand, how the web console looks like, and the details of it. In case if you have like, you can say a terminal like a database and you want to access the database, you can use the terminal to run any commands, such as SQL commands. Now we want to just access the application. So the application is a simple bTravels currency data service. So you will see, it will look like this for you. And if you click on currency, it will show you the different API requests that you can make from GET and POST. So you can do a search and you can do currency, like, this can be, for example, saying what is the value of this amount of currency in another currency. So say we want to try it out. So Swagger is actually a really useful tool if you want to explore how it's how your API requests are working. So in this one, we're going to convert to, let's say, from AED, which is Arab Emirates dirhams, to USD, US dollars, and then say we're going to have $10. We want to convert from 10 USD dollars and see how many dirhams it will cost or value. Yeah. So hit execute, and you will see all of these responses. You can also use a curl to see the request results in your command line, and you will see that here is the result here. So the result is 11.64002. So in case if you're facing currency code not found, let's try something else. It worked with me just now, but I'm going to try again. I think this is fine. This is not an error, because otherwise it will show you the error here. Since it gave us a result, but I believe this isn't accurate or something, or maybe I have mixed things. Let's try. So it's converting. Let's try $1. Much easier. Yeah. Okay. Anyways, you can also run the command. So like curl and then get command. We can do it on the CLI. So this is the Cloud Shell in case if you do not have a specific commands, or if you cannot run curl, you can just run it there, and you will see the result here. So that's one thing. And so I just quickly showed you how to use the web console. So hopefully that was not quick. I can also, show it again in case if you want to see again how it works. But now let's jump into trying it with the CLI. We're going to deploy the same application with the CLI. And first you have to start with going to the top right corner, you see, and click on your username, your email, and you will see a menu, like a drop-down menu. There is this option, copy login command. So make sure to click on it. This will give you a token that you can copy into your CLI. So copy it and go back to your Cloud Shell, paste the command, and yeah. So it's showing you right now that we're using the default project. We want to create a new one, because do not create applications in the default project, because it can also cause some problems for you. So how can you create a new project? Use OC, new project, and then give it a name. So Flask app 2. Of course, it's a project, not an app. So in a project, you can have multiple applications. So next thing is we want to create our application, and that can be done using the OC new app command, and then we're going to add the name of it. So let's see here. You will see the command here as well. In case if you want to copy it, just make sure that you're going to provide it with the right naming and tagging. So it will be the username and then the name of the image. So yeah, I think let's just copy this one here. Oh no. Okay, I'll see a new app. No. Okay, I have to write it on. I think it's copy the space along with it. So and then make sure to add the tagging. So V0, V03. Okay. You can also add the name of it if you want to give it a specific naming, like using the dash name. So there you go. You can check. You can use OC get pods to check the status of your application, and it's currently running. But if you go with OC get service, so the service is like what is created along with your application. So you can access it internally or externally. You will notice that it cannot be accessed externally at the moment. If you do OC get routes, the route is what we are going to use to access our application from a browser or from a phone, anywhere. And you will see that there are no resources. So we're going to need to expose it. When you are going to use the OC new app, the command, you have to expose the service that you're going to create. So just type in the OC expose and then service, and then the service name, which is currency exchange Pi. So once you do OC get routes again, it will show you the link to it. Now this is going to be insecure link. So if you copy it at first, it might give you an error. So because it is an HTTP URL, not an HTTPS, and as you can see at the start, it started with HTTPS. Now you can create secured routes on OpenShift, but the simplest, easiest, and most straightforward way is to just use OC expose, even though it's like not really recommended. And now you can access your application. And it works the same way as the other one I just showed you. You can check the application in the topology. So just make sure to check to go to the project in the web console, and there you go. So I mean, I just showed you how to quickly build and deploy your application on OpenShift. I forgot to mention one thing is the container images, which are like the list of base images where you can find them if you want to explore more, because we mentioned so many images and resources that you can use to build your applications. You have the UBI image, UBI init, UBI minimal, and so on. So you can see, and that some of them are based on RHEL 8 or RHEL 7. You have the runtimes such as Node.js or Python, and so on. So if you go to the catalog and search for base image or UBI, you will find all of these images. Just make sure to check the base image mark here, and you will get to see all of these different base images around. So the one that we are using, let me see where I can find it. UBI 8. So this is 7, and then this is 8. You have UBI minimal, init, and so on. You can also find the different runtimes as well, like not just UBI. and you can get an idea of, like, what does this image do, description, all of the details about it. So yeah, I highly encourage you to take a look at it, especially if you want to build and deploy different applications. So if you have any questions, feel free to ask us right now, because I'm actually I already finished the lab. So feel free to build your own images locally and then use OpenShift to perform the same steps that I did just now. And yeah, I think that's it from my side, but I will be waiting for a few minutes if anyone has any questions or need any kind of clarification. And Asna, would you like to add anything else?
Yep. If you're done, let me share my screen.
Sure.
Awesome. So I really, by the way, enjoyed the workshop, hands-on. It was really fun. So guys, for those of you who are new and don't know, Masa and I are from IBM Developer Mia community, and we have our Facebook group where we can, you guys can join us. Even if you're not from the Mia, you're more than welcome to join us and, have a conversation with us about technical topics. And if you're trying out some hands-on workshop from one of our events and you're facing any issues or difficulties, you guys can ask us questions there. So please do join our Facebook community and let's be a big, happy technical community. And moving further, please let us know how we did today, right? This is a survey link. It's a very short, quick survey of less than a minute. So do let us know if you enjoyed our hands-on workshop or if you enjoyed our session, and overall what you thought about the developer festival, what we can do to improve. We would love to get your feedback, and what all sessions did you guys enjoyed. I hope I better be in that. And moving further, yeah, and these are some of the resources that we would share with you. Masa would also share them in the chat, and then we can also send them to you in the follow-up email. So if you're looking to learn more about how universal base image, so we have a complete learning path that you can follow. We also have like Red Hat UBI link where you can go and get your more knowledge in this field, and then Red Hat UBI on Docker Hub as well. So if you're interested to learn more, go ahead and try out these links. And yeah, thank you so much for being patient with us and joining us today. Again, my name is Asna Javed. You can, reach out to me on my email address, or you can connect with me on LinkedIn or on Twitter. And then we have Masa. Oh, Masa, I'm sorry, I forgot to throw your Twitter handle in here. So you can reach out to Masa on LinkedIn, and as well as you can send her an email. And yep, Masa will share her Twitter handle with you in the chat. So guys, do let us know how did you felt, and I hope you enjoyed it. This was a very great session for us. So yep, have a great session for the next one, and which would be, I believe, the last session of our developer festival. So take care and bye from my side.
Thank you, Asna. Just before we leave, I just noticed a question. Someone was asking, what is the purpose of API layer in the demo? So it is just showing you how, would have like kind of like a tier architecture, because like in a real life scenario, you would be having an application that acts as a web server or backend and connects with the UI and any APIs you are using. So this is the purpose of it, to just show you how it would look like in real life scenario. But it can be anything, to be honest. Like the application does not really depend on the API itself. Like you can use it, if you don't have to use it, if you want, feel free to do whatever you like when you're going to explore it. So hopefully this answers your question, and feel free to reach out really. for any questions. We're happy to, we're available like all the time. Yeah.
Yes.
Thank you so much. Yeah.
Yeah, thank you so much. And over to you, Miriam. Oh, by the way, guys, we wrapped up earlier than our time, so let's have a quick short, like 10 minutes break, and then obviously we can join for the last session. So go ahead, grab some coffee if it's like evening for you, or if it's an afternoon, grab some snacks. And yep, let's see you guys in 10 minutes with the next speaker for sure. And have a good rest of the week. Bye from my side.
Hello, everyone. We're just getting started or getting ready for the next session. So the last session today is CI/CD for Kubernetes, and Adzo is joining.
Hello.
Hello.
Do you hear me?
Yes, I do.
Excellent.
Super. Welcome to the Developer Festival. Great to have you with us.
Thank you for inviting me.
Of course, of course. So I'll stop sharing my screen. Maybe actually I'll just take us through a couple of housekeeping before we get started. So if you're new to Crowdcast, big welcome to you. And you can let us know in the chat where you're joining us from today. My name is Miriam Oglesby, and I'm joining from Berlin, Germany. There's a chat here on the right. At the bottom, you've got the possibility to ask a question. There's polls, and also the big green button is where you can sign up or sign in to our cloud workshops. And I just remembered, Adzo, we're using a different link. I'll change that. So if you'd like to follow our channel for more developer talks and hands-on workshops, there's a follow button in the top right. And if you'd like more information about the Developer Festival, you can click on that link at the top on the left. So, yeah, today has been a cloud day, and really excited for this last session today with Adzo and CI/CD for Kubernetes. So I'll stop sharing my screen. And I'll put the new link into the chat as well. Great. Adzo, do you want to start sharing your screen?
Yes. Thank you very much. Just let me know when I should start. You see my screen now?
Yes, looks wonderful.
All right. Miriam, thank you. Welcome everybody to our last webinar in this series today. I hope everybody's still fresh and energized. You had some time for a coffee and refreshments. We won't be very long with this session, and hopefully we will be very interesting. So this session is all about the continuous integration and continuous delivery for Kubernetes. We will have few presentations and demos, and then you will have the opportunity to do some hands-on exercises if you are interested. The workshop materials, all right, you see them in the chat room. Excellent. So this is our agenda. So first we'll cover a few, few terms just to make sure everybody is on the same page. Then we'll talk about the delivery pipeline and something called Toolchains for IBM Kubernetes service. And then we'll look at the continuous delivery service on IBM Cloud. So all the examples that we will show will be on IBM Cloud. So this includes also the tools that are available on IBM Cloud. And then we will have a couple of demos and hands-on exercises, which are optional. Those of you who want to do the exercises, you'll be able to do it. And those of you who are not very interested in that part, you can just watch me do those exercises. And at the end, we'll have some fun. We'll have some short quiz to see what we learned today. And with this, let's kick on with a few terms. So let's first explain what do we mean by continuous integration and delivery and deployment. I thought we should explain this because there are different definitions. If you go in Google, you'll find different definitions. So this is what I will use today. So by continuous integration, what we mean here is a set of DevOps practices that automate the integration of the software code and software code changes from multiple developers into one single, consistent software project. And a part of this practice is bringing the code together, testing the code, and packaging the code into something that could be, deployed. While the continuous delivery is all about those software code, projects to automatically build them into some, deployable artifacts, and then test them and prepare for a release to production. And once all this is done, the release to production could be done just by one button push. Now, continuous deployment is something very similar. There is a slight difference from delivery. The difference is that the continuous deployment also includes the automatic release. So continuous deployment would be something what is today often mentioned with word GitOps, where basically you go and you just change your software code in the Git repository, and everything else is then done automatically, and software is deployed to production automatically. So this is what we mean by CI/CD today, and I'll use just the abbreviations for the rest of the session, CI and CD. All right, so I will use a demo application to show with examples how this things work. This application is actually a chat application, so we can all use it and chat with each other. We will use it to test and to show and to prove, how the CI/CD work. So those of you who like to join us in testing, the app is available here. If you put, oops, sorry for that. Let me see if I can still type into the chat room here. Oh, yes, I can. So if you put in ibm.biz/chatroom, you will get the app, which is running on cloud. And let me show you what it does. I will open it now. So I think you see my app now, right? So what we do here is we log in to the chat room with our name. So you can put any name, like I'll put my name. And then it is important that if you want to chat with people, you all log into the same chat room. We can give any name to this room. So let's give it a name, I don't know, festival with small f. So if I join here, and hopefully there'll be some other people, right? Miriam has joined, so we can chat here. We can say, hi, Miriam. Sorry. Alex is here as well. And there are more people joining, right? So this application is actually, it's a Node.js app deployed to Kubernetes cluster on IBM Cloud. And I'll show you how we can update it using this, GitOps principle, just change the code and push the changes to Git repo, and in a few minutes the app should be updated. So let me do that next. I will update this app. I'll make just a small update, just something that will show that an update was done, right? So let me go and open the code editor. And here is my code. I'll just change, let's say, okay, let me show you what I'll change. I will change, just let me go back to the, all right, I'll log out. You guys feel free to stay here and continue chatting. I'll just log out to show you what I'll change. So I'll change the title. Instead of let's chat, I'll change that to something else, and I'll change the color of this button, just to show I did some change, right? So the title, I'll call it, instead of let's chat, I'll put chat room, save that, and then change the color in this CSS file. So change this green color to blue or purple, okay? Save that, and now add changes to Git, commit changes with the message, change title and button color, and now push changes to Git repo. And in the background, I will show you what happens when I push these changes, right? So let me show you how this works. This is my delivery pipeline of this app on IBM Cloud. And I will explain all of these details later. I'll explain what we see here and how is this relevant. But I'll just want to show you now what happens when I push these changes. What should happen? So what should happen now is I push changes, and if you look at on the left-hand side, my pipeline, you see the first stage in this CI/CD pipeline here is built. I'll explain later what is this. But anyway, in this stage, what is going on here, my Git repo is being constantly monitored. And when a change in the Git repo is being noticed, then the build will start and deployment and everything, right? So when I click push here now in my code editor, now watch in the background on the left side what happens with this build. Okay, so I got a message here. Push was done. And see what happens here in the pipeline. So the build stage, this color changed to blue to catch my attention. The blue means something is running. And you can see the last commit message is what I actually did, a few minutes ago, including all the typos I did, right? So this will now run a few minutes, and in few minutes, the app that we are using now to chat will be updated. So this is our small demo app. I thought better to use something that could be used by people rather than hello world. And now let me go and explain how this works. I will go back to my PowerPoint, and for those of you who would like to test all of these things that I'm going to show in the next hour, we have exercises prepared, and those exercises will run on Kubernetes on IBM Cloud, which is the reason why you want to create your Kubernetes instance first for yourself, in your IBM Cloud account. So those of you who want to do this exercise, here is what you do. So in our materials of this workshop, the link that you have in this chat here in Crowdcast, right? So in this materials folder, find this file titled lab1 create IKS cluster. It's a PDF file and you can open it and read it. There are instructions how you create your Kubernetes cluster, or you download the file, whatever you prefer. It will take you less than 5 minutes to create this cluster. The reason we want to do it now in the beginning of this session is we will have to let it run for the next 15 minutes until the cluster is created and all the environment is set up for you. So that's why let's do it now, and then in 20 minutes you'll be able to work with it. And I will show how actually you do it. So let me go back to my web browser. All right, so this is my pipeline. Let me go back and show you how you create your Kubernetes cluster. So this is my IBM Cloud Console. In this search box, I will type in Kubernetes. And I should see this thing called Kubernetes service. So this is a managed service which will run my cluster if I create it, right? IBM will manage it, takes care it's running and all that. So you want to see this Kubernetes service here when you type in this search word, and then I'll show you what to do next. But first, let me tell you this. If you don't see this Kubernetes service, this is because your cloud account type is light. It's a basic cloud account type. This basic cloud account type, light, does not offer Kubernetes service. So there are two things you can do about it. One, upgrade your cloud account type to the type of pay-as-you-go. That's how it's called. And when you do this, you will need to provide your credit card number. You will not be charged anything. You just need to provide it to create that account. And if you don't want to do that, if for some reason you don't want to provide a credit card number, here is the second option. We can temporarily upgrade your light account for 3 months or 6 months. So you'll be able to use Kubernetes service and some other additional services. And after that expires, after those 6 months expire, then you will be asked to upgrade your cloud account to pay-as-you-go type. So those of you who want to use this opportunity to get this, temporary upgrade, here is what you can do, how you do this. My colleague, Alexander Gavrin, can give you a coupon which you apply to your cloud account. And, as soon as you apply this coupon, you'll have your account upgraded. So, Alex, I hope you're here and you hear this, right? So could you please put into this chat room here in Crowdcast, could you please put the URL of the coupon request? Here it is. Thank you, Alex. So if you look at this chat room here in Crowdcast, people use this URL to request this coupon. So this will upgrade your cloud account from type light to type trial. So when you go there to this website, you'll just provide your name and email address and send the request, and in a minute or 2 minutes, you will get this coupon to your mail. And then once you have it in your mail, you just copy it and paste it in your cloud account. And if you will need any help with that, just write in the chat room. Alexander can help you in applying that coupon to your cloud account. All right, now let me show you how you create a Kubernetes cluster. So let's go back to our Cloud Console. Here is my Kubernetes service as one of the options returned by my search. I will click on the Kubernetes service, and now I can create a Kubernetes cluster. So there are several options here I can pick. I can pick the pricing plan. If I choose the free plan, I don't pay anything. I will get this free cluster for 30 days. After 30 days, the cluster will expire. It will be deleted. And after, I can create another free cluster for another 30 days. On the right-hand side, I can see what is the price of this cluster. It's free, right? If, on the other hand, I would want to create, something more powerful that I could use in production, I would select standard cluster, and then I have options to configure it, to specify, where exactly in which geography I want it to run, and then I can define the configuration, the number of CPUs and memory, and many other options. And all the time while I will be changing this configuration, on the right hand side I will see what it will cost me if I create such cluster, and I won't pay anything at all until I click on this button, create. But we won't use the standard cluster in this demo. I'll use the free cluster. So what I will do here is just specify free and leave all of the other fields default as they are. I wouldn't change anything. And on the right hand side, I would click on the button create, and then this would start the creation of my free cluster. I will not do it here because I already have one free cluster. I cannot have two free clusters. So I even cannot create another one. But this is how you can create it. So, and that's how you go and create your Kubernetes cluster, and then you leave it for 15, 20 minutes until it's created and ready for use. And if there are any questions, I see that I can actually monitor the chat all the time, even when I'm sharing the screen. This is good. So feel free to post questions in the chat, and I will go back and share my presentation. So we'll continue with the presentation. All right, so let me tell you a brief overview of the CI and CD on IBM Cloud. What it has, main things. Okay, so it gives you an automated delivery pipeline. A delivery pipeline is a workflow, a series of operations that take the source code of the application, and through several stages at the end deploy that source code, right? So this is all fully automated, and you have a control in how much automated you want it to be. You can make changes, for example, and decide that some parts of it you want to rather have some manual control, and I'll show you how this is done. Then all this workflow, this delivery pipeline, is actually performed by a set of tools that work sequentially one after the other. So one tool, for example, is monitoring your Git repo, and then does something with the source code. Another tool would package the app into containers. Another tool will deploy it to Kubernetes, and so on, right? So this set of tools, we call it a tool chain, because this is how it works, like a chain, you know, sequentially. The code editing can be done, but not necessarily have to be done using an integrated web-based IDE. So you saw me using Visual Studio Code. Earlier, I could also use a web-based IDE that is being created automatically for me when I create such a delivery pipeline. And there are some nice things about such web-based IDE. I could use it from any computer anywhere, right? I don't have to have, you know, my IDE on this computer, where I am currently. The Git repos that are being used could be GitHub, could be GitLab, could be Bitbucket, or it could be IBM Git repo, which is you know, GitLab version on IBM Cloud. It has a really neat feature called Vulnerability Advisor, which scans the application's source code and looks for vulnerabilities, primarily security vulnerabilities and potentially also some legal vulnerabilities, and also provide an advice what to do if such vulnerability is discovered. I will show you that actually in our demo code, there is some vulnerability, so you'll see what we can do about that. And then there is a useful feature which can be used to analyze our whole DevOps process, analyze how it works now, how it behaves, and propose some improvements by defining something called policies, and then monitoring how these policies, what effect they have. Is our DevOps process now better or worse, and so on. So we will look at all of this, what I mentioned here. So let's dig in. Now, first, let's talk about the delivery pipeline. I mentioned this is a series of operations, a workflow of operations that do both the continuous integration and delivery and deployment as well, all in one set of operations. So here is an example. You could have different kinds of delivery pipelines. You can create your own delivery pipeline and specify what tools will be there and what they will do, and so on. And I will show you now a simple delivery pipeline, which we will also use with our demo chat app. So this simple delivery pipeline is made of 3 stages, named build, containerize, and deploy. And this little image in the middle of the screen, that's literally how it looks like. We work, it has a GUI interface. So the build stage, this is how it looks, and the containerize is the next stage, and then deploy is the next stage. So these 3 stages run sequentially. The first stage is building, executable artifacts out of the source code. The second stage, creates a Docker container, and the third stage deploys the Docker container to Kubernetes. Now, the sequence is from left to right. Obviously, you need to build it first. They all run automatically. They are triggered by any change in the Git repo. So each stage has something in common. Well, it actually has several things in common. So, for example, each stage has at least one job or more jobs that perform specific tasks, task specific for that stage. Each stage has its log and its history, so you can check what happened on the job level, actually. So each job has its log and history, and each stage, by default, when you create it, is being triggered automatically, but you can change all of that. You can make any one of them, manual triggered, and you can reconfigure each of those stages by adding job in a stage, or removing a job, or changing a job by reconfiguring that job, or you can even add additional stage. So for example, in this case, maybe you would want to add a stage that will do something about, security checking, for example. And you can do this really, quickly. For example, you could do it by cloning one stage and then reconfiguring it. You can reorder them. And you can do all of these things, what I mentioned, using the settings of each stage. I will show you live how this is done. Before we go live, let me just explain a few things. So the stage one built in our very simple pipeline. So bigger picture of our GUI of this stage. So it pulls the source code from the Git repo, and it has two jobs. The first job fetches the code and also, writes down some environment variables that are being, used later. The second job in this stage is actually a placeholder. It doesn't do anything, but it is there as a placeholder for any unit tests, if you want to do them on that source code, right? And if you look at this job, the fetch code job, we see what it does. We see that it is building something, and it's using a shell script to build that. It could use some other script, doesn't have to be a shell script. This one is using shell script. And then below you can see what script it's running, right? So in this case, you could put here, the script. You could copy a script here, or just put a URL to the script that is somewhere else, right? Now, the interesting thing is this checkbox at the bottom, which says, stop running this stage if this job fails. You can uncheck it, and then your delivery pipeline will run even if this stage fails. Why would you want to do that? Well, you probably wouldn't want to do that for this build stage, but you may do it for some other stage, and I'll show you an example very soon. So, and then the stage two of our very simple pipeline that we'll use in the demo, it is containerizing our app. It has 4 jobs. The first job is checking the Docker file. It checks whether there is a Docker file, and if it finds it, then it checks it for correct syntax. And then the second job is checking whether there is a container registry existing, the namespace that is, and if it doesn't exist, it would go and create it. The third job would then go and build a container image out of the Docker file and stores that image into the container registry. And the fourth job would check for vulnerabilities in the code, uses this feature called Vulnerability Advisor. And if it finds any issues, it would report those issues in the log. And then we have a option to do something about it. And the third stage in our simple pipeline takes the image and container and deploys it to our Kubernetes cluster. This stage has two jobs. The first one is deploy to Kubernetes job that does all the work that we would normally do manually to deploy an app to Kubernetes, including, creating the configuration files, YAML, and configuring the cluster namespace and all that, setting the environment variables so it would deploy our app to the cluster, and then it would go and check health of the pod that runs our app. So these are the three stages. We will have a look at them a little bit later when we will go and create a new delivery pipeline, or maybe you will do it in using our hands-on exercise. Let me move on here to the next topic, which is the tools that perform all this work I mentioned in the delivery pipeline. So we call them a Toolchains because there are a set of tools working together one after the other. Some of those tools, I'm sure that many of you are already using them, but when these tools get integrated, the sum total of them is much bigger than using individual tools one after the other. So such toolchain is really what you create. So when you want to implement a CI/CD, you go and create a toolchain, and we will show how you do that. And once you and this is all through GUI. So you basically, there is very little manual input by providing some names, and you'll see what you provide manually, but mostly it is GUI and automatic. And once you create such tool chain, then this triggers a creation of a continuous delivery service on IBM Cloud, which then runs the tool chain and the whole CI/CD pipeline. And there are many tools that you can pick to include into your tool chain. Here are some of them listed. I'm sure some of them are very well known, like Jira and Jenkins and GitHub and Slack and so on. So for those of you who want to learn more about these tools, look at this link at the bottom of this slide, which says more info. So wherever you'll see the more info on any of the slides, this is where you can get details about the subject on that slide. Now, let's have a look how you go and create such toolchain. So you can create it in one of the two ways. One way is you create it from scratch, which involves a certain amount of work, or you use a template. You use one of the toolchain templates. And I would recommend to use that because it's quicker. You use a template and you have your toolchain created quite quickly. And once it's created, you can then modify the toolchain that you created out of the template. You modify it, change, reconfigure it, add tools or stages and so on. So these templates are quite useful, and we will use one template in a demo. And I also want to tell you briefly about different templates that are available for Kubernetes. There are 8, maybe 6. Sorry, this changes. There is a number of different templates that can be used for Kubernetes, and then there are many more templates that you can use to create toolchain for apps that don't run on Kubernetes. Maybe they run on Cloud Foundry, for example. All right, now let's have a look at these templates. So the first template is the most simple template. Each of these templates have a name. So when you want to use them, you go and find them under the name of that template, right? So this template, the most basic one, has a name, Develop a Kubernetes App. That's how you find it. So what it does, it deploys your app to Kubernetes, right? It creates a toolchain that looks like this. What you see on this screen. So in the middle, there are 1, 2, 3, 4, 5 tools. GitLab for issue tracking. So it's actually an issue tracker. Then a GitLab repository, web IDE, delivery pipeline, and then run it on a cluster. If you use this template and you don't change anything, you just create it as it is, what will happen is it will take a sample application, which is a hello world, surprise, surprise. And you can replace the obviously hello world with some other, Git repository, and then it will be another application that will be deployed here. It includes the vulnerability advisor to check the security of your container images. It includes also a useful feature called Code Risk Analyzer that is useful if your app is written in either Java, Node.js, or Python, because it checks the code for regulatory compliance. And then it includes, the source control, which is Git, the issue tracker, and the online editor. To use such template is pretty straightforward. We'll show it today, but also if you want to learn more about it, you can use one of these two tutorials that you see at the bottom. One is the classical tutorial, and the other tutorial is using Tekton. So that's template number 1. The template number 2 is called Develop a Kubernetes Application with Razi. Razi is an open source project that you can use to manage the deployment of Kubernetes resources across different clusters, which could run also in different environments, including different cloud providers. So to use Razi template, a template that includes Razi, it will include most of the things, most of the components are the same as in the template number 1. The addition here is the Razi configuration, which you can see here on the slide. So if this sounds interesting, like you want to do something across different environments, I recommend to have a look into Razi, and you see at the bottom where you can get more information about Razi. Template number 3 includes Helm. So you can use that if you're using Helm, and it will be Helm version 3. So basically it's using what you get with that, the same, Hello World app, which you can replace obviously with your Git repo. And it also includes a Helm chart. And the rest is the same, the vulnerability advisor and, the others. Template number 4 is something that is useful if your app is made of different microservices. So the way how that one works, if you look in the picture, let me use highlighter. So this delivery pipeline is made of three delivery pipelines, because there are 3 microservices. in this code. This code is actually an e-commerce application. The 3 microservices, what they do, one is the catalog of items that are being sold. The other is the orders. That includes also an SQL database, and the third one is user interface. And these microservices in this example, they're written in different programming languages because they can, right? In the microservices, this is possible. Well, anyway, the delivery pipeline that you get with this template will have 3 different pipelines that are then being merged together into one, 3 microservices being put together in the app and deployed to the cluster. So that was template number 4. The template number 5 and number 6 are similar in a way. The similarity is that you can, so the template number 5, you can use it if you want to slowly roll out your new version of the app. So let's say you're making some changes. You don't want to roll out all of those changes to all users at once, but just to a small subset of users using this, canary testing. So that template will be configured for canary testing. I recommend to have a look into this one, and there is a tutorial as well with all the details which explain how this works. And the toolchain template number 6 is using iterate, an open source project that can also be used for propagating changes to a small subset of users, but it also has some other very useful analytics and business metrics. So if this sounds interesting, I suggest to look at the iterate page and the tutorial for this template. So these are the 6 templates that are available. You can use any one of those, right? We will use template number 1. And I will show you shortly how this is done. I'll show you this live, but let me just explain. So this is done in a Cloud Console. You go, in a menu in the top left, you will go and click on the DevOps option, and then you'll go click on the Create Toolchain, and you'll see a list of many templates that are available for you. You can narrow down this list to just those templates that are doing something for Kubernetes, and then you'll go and create a toolchain. So in the case of our the simplest actually template called the developer Kubernetes app, on this slide and on the other 2 slides, basically what you see is some screenshots that show you how to do it. I will just skip this because I will show you live how to do this. And I'll just mention a few things here before I go to demo. One is when you create a toolchain, this will automatically create continuous delivery service, and you will be able to find it, see it under your resources in Cloud, IBM Cloud menu under the services category. And the last thing I would like to cover in the presentation is something called DevOps Insights. DevOps Insight is actually an application. It's a solution that is available. You can integrate it into your toolchain. And what it does, it analyzes your DevOps process. Now, how can it analyze your DevOps process? Because it is monitoring your toolchain, which you use for DevOps. It's monitoring all the stages in the toolchain and analyzing, some parameters, and providing you an advices how to improve the speed of DevOps process or quality, or how to have it more controllable. So what it does, it is aggregating data using some scanning and testing tools that are attached to your toolchain. And then it provides you with a dashboard, a dashboard as in some graphical representation of all of those metrics that are easy to grasp. For a human being, it shows you the trends in your, by analyzing your DevOps process in the past, and proposing you changes, showing you what trends you can expect if you don't change anything, or if you do. It allows you something called a policy establishment. So you basically go and define how your DevOps personnel should work, the timelines and so on, and then you'll monitor those policies once they are being established. You'll monitor, is your process now doing better? Is it faster? Is the quality of code better, or were there more bugs than even before? And these are the four views. There's a quality dashboard where you can basically monitor the quality of your code, the risk analysis view, and so on. I will switch now to a short video, 3 minutes video, that will demonstrate these DevOps insights. And then, if you will find this interesting for you, we have one of the exercises today, one of the 3 exercises will be about the DevOps insights. You'll be able to use it and see, what it can do for you. So let me just show you now this quick demo, which is a video, as I mentioned, on YouTube. And I'll start it. And I think in the beginning, the sound may not be the best, but that will be just 1 minute, not more, and then it gets better. Give me a second, please. My mouse froze. So I need to do something with my mouse now. Okay, here it is.
Hello, and welcome to this IBM Cloud DevOps Insights overview demo. IBM Cloud DevOps Insights is a cloud-based solution that aggregates and analyzes data from popular continuous integration and continuous delivery tools to improve the speed, quality, and control of your applications. With DevOps Insights, you can view test results and trend information about your builds, deployments, and tests to understand changes over time, ensure that quality code is delivered to production through the enforcement of policies, and explore code and team dynamics to help you understand better how your team interacts and to improve the quality of code that they produce. So let's get to the demo. We begin with the quality dashboard, where we can see test results as aggregated from all of our DevOps tools across all of our applications. We can filter the results based on the branch of the repository that we're looking at. In this case, either the master branch or our release branch. And we can configure either the data we're looking at or the applications that are visible to us on the dashboard. Clicking on any link takes us to a detailed description of the results of our testing. So in this case, we can see all the tests that were run on this particular branch for this particular application. Taking a look at code coverage, we can see we're at 60% code coverage, and unit tests, 100% of them have passed. We can drill down even further if we need to. We can also look at trends over time. In this case, we're looking at the number of tests that have been run for this particular application in the last 90 days. But we can change any of the data sets, any of the date ranges, or any of the environments that have been deployed to, in this case, production or staging. In addition to quality trends, we can also take a look at our deployment and build frequencies. In this case, we're showing that we've deployed a number of applications and some have failed. Drilling down, once again, we can click into and take a look at the detailed results. Finally, all of this data can be used to build policies for our continuous delivery pipeline. So for example, in this particular policy, we're aggregating a number of different rules, and we want to make sure when we reach that quality gate in our pipeline that these rules have been met before we pass on to the next stage. We can edit existing rules, in this case, raise our code coverage to 70%, or we can create new rules to add to our policy. Finally, we can take a look at the risk analysis for our applications, and we can view that either on an application basis, so we can see the results for each of the builds per application, or we can see it on an environment basis, where we can see the results both in the production stage and in staging. So that wraps up our demo. We've talked about aggregation of data, we've talked about trend analysis, and we've talked about policies. For more information about DevOps Insights, follow the links on this slide. And thanks for watching.
All right, so that was DevOps Insights. Now, we are done with the presentation part. So let's have some fun. Let's do the quiz. So everybody, you're kindly invited to join us with the quiz. You can join us in two ways. One, you go to your web browser to the slido.com and then enter the code for this quiz. The code is 442098. You enter the code in this field that looks like this, the field titled joining as participant. The other way, you may want to join us from a smartphone, for example, just scan this QR code. And you can participate in the quiz. And when you log into the quiz, you will be asked for the name. Keep in mind that we are recording this, and if you want to stay anonymous, provide a nickname, right? Or a fake name. So let's see. There is one person who already joined. Let's give a few more, let's say a minute to others who want to join it. Okay, 2 people joined. The quiz is quite short. There are 5 or 6 questions. And for every question, there is 20 seconds time. And also, for every question, you get some potential answers. Yes, Miriam, we could have the questions now after the quiz. Just saw your message in Slack. So yeah, the questions in the quiz. So for every question, you'll get a few potential answers, and then either one of the answers will be correct or maybe more of them. If there is more answers correct, then you'll see that there are more, right? So we will go and also publish the leaderboard after each question, where you will see how good you are doing compared to the others. And the leader is obviously the person who has the most questions correct and was faster. So if 2 people have the same amount of the correct answers, then the person who spent less time is leading. All right, we have 8 people in the quiz now, and there are people still joining. This is great. I'll wait a little bit more. We have 10 people now. And it seems that 10 is, it seems that we are 10. All right, so let me start the quiz. Get ready. So you'll see the question written, obviously, and then you just pick the correct answer. All right, here we go. Question number 1. If the delivery pipeline fails, the next stage will never be triggered. True or false? Most people say false, and this is correct. Maybe it was a little bit of a tricky question. The keyword here is never. You could configure your pipeline and make a stage in that way that it has to be successfully completed in order for the next stage to be triggered, right? Or you can say, no, doesn't matter, you just go on. So this is configurable. That's why this answer is false. The keyword was never. All right, let's move on to question number 2. Oh, the leaderboard. The developer is in the lead, followed by Mike, Paceman, Sam, Devman. The difference is few seconds between them. Let's move on to the next question. You can use Toolchain only with Kubernetes. The correct answer is false. You can also use it in the other environments, such as Cloud Foundry. Developers still in the lead, 3 seconds faster than Sam and additional 2 seconds faster than Mike. This is very, very interesting. So let's move to the next question. Can you add new tools or remove existing tools to a tool chain? Yes, you can. This is configurable. The developer is still leading. 6 seconds before Mike, an additional 2 seconds to Sam, and 11 seconds to Devman. Get ready for the next question. Okay. Which of these work with the IBM toolchain? The answer is all of them. All of them. So we have 4 people who got all answers correct. And the last question. All right, this is a difficult one because I did not actually explain it. Sorry for that. you may know this if you already explore this topic. Otherwise you would, I guess, have to guess. Okay, so the question is, which of those are available as a managed service? You can use all of them, but as a managed service, there is Jenkins and IBM Toolchain. All right, so let's see the final leaderboard. The developer is the winner because he or she was 2 seconds faster than Sam, who was 9 seconds faster than Mike, and Devman was also very close. Congratulations. Now, let's see what time is it. It's 5 o'clock. It's time for demo now and the labs. So Miriam, what we can do here now is either take questions if there are any questions, or maybe make a short break, like 5 minutes or so. You just tell me what you prefer. Or 10 minutes break, anything.
Sounds good. As you wish. We just have one question in Crowdcast so far. We can take a quick break if you fancy.
All right. And what is the question?
The question is, does the container technology have to be Docker? What other technologies can we use instead for image building?
Yes, thank you for asking. This is very interesting. No, it doesn't have to be Docker. And interestingly enough, Kubernetes on IBM Cloud is not using Docker containers. It's using CRI-O containers. But when you create an image, you know, anything that is Docker-like, meaning complies to this standard, which right now I can't remember what was the name of this standard. Which Docker complies. So any of those will work. And then when it runs on Kubernetes on IBM Cloud, it won't even use the Docker containers. OCI, thank you very much, Iqbal. Right. Okay. So if that was the only question, Miriam, what do you think? How much break should it take? For me, I'm fine. What do you think people need here at this point?
As you see fit, we've had the 10-minute break before this session.
Shall we take 10 minutes?
As you wish. Sure.
All right. Let's come back in 10 minutes.
Okay, I'll put up a note on the screen that we'll be back.
You know what? I'll put it on in my slide.
Okay.
I'll just put in the counter so we'll see when we are back.
Perfect. Thank you very much.
Sure. It will just take me a minute to create this counter and then I'll share it.
I love the quiz, by the way. That was great fun.
Yes, thank you. You see my screen, yes? All right.
Oh, that's perfect. Thanks, Satsu.
All right, so we are back, yes? Okay. So it's time for a demo or hands-on lab, whichever you prefer. The lab instructions, you see where they are, in the same place where all the other materials. I will show you the lab, a demo of the lab 2. So going back to my web browser, let's first check what happened to our chat app when I, updated this code. What I did here is I think I changed the title. I don't even remember well. I think I changed the title and the color of this button. So if I press refresh here, that should change. Let's see. Yeah, so you can see that application was updated, right? Now, in the lab 2, we'll actually do the same what I did in this short demo, but we'll go from scratch, starting with creating a tool chain and then, deploying the app and making the updates and so on. So let me do that. I will go, this is my cluster, Kubernetes cluster in IBM Cloud. I go here to the DevOps. And I see here there is one tool chain already. This is the one which I was using. I will create another one. And here I get the option of different templates. These are all the templates that are related to Kubernetes, plus few others. So I'll pick this template, develop a Kubernetes app. And I need to provide it now with some data, right? So I'll give it a new name here. Name of this tool chain, just keep it as default. Region, I'll keep it in Frankfurt because it's closest to me. I'm based in Slovenia. Frankfurt is relatively close, right? And I'll keep many of the other parameters as default, including the source provider. I'll select Git repos and issues tracking, and then scrolling down, I need to now give some data about these Git repos. So I'll say, have it in Frankfurt, in the same place where this toolchain is. Obviously, it makes sense. And now I can, here are a few options, what I can do when I want to specify the repository type. So by default, the system is offering me to use this Hello World app, which is stored here in this Git repo. But I could do that, right? But let me show you how this chat app was deployed. So instead of these Hello containers, I'll say clone a repo where my chat app is. And let me find the address. Okay, it's this one. So this is my repo with the chat app. And I'll put it here. Repository owner, that will be me, and I'll give some name of this to this repository. So it will clone the repository from GitHub to GitLab on IBM Cloud, and I'll give this name. I'll just call it chat app containers, and I'll go back to name to also call this. No, I'll just leave it, just to make sure it's different. I'll call it Cube Toolchain. Click create, and now I'm asked to provide an API key. This API key will be used for communication between the toolchain and Kubernetes cluster. So if I have an API key already, I could specify it here. If I don't have an API key, I can create it. So I'll create it right now. Leave the default name to this API key and click OK. And now these fields at the bottom will be automatically populated for me. They say basically where this is data about the container registry that will be used here, you know, the location, the namespace for this registry. It is using the registry namespace, which I already have. Otherwise, it would create a new one if I didn't have any, right? Here I specify what Kubernetes cluster to use and also the namespace. So pay attention to this one if you want to go and track what's happening to your pods and services and so on, you know, related to this application. So keep this in mind. They will all run in the cluster namespace named prod here. So click on create. And now my tool chain is being created. I'll just skip here. So I see this is a basic tool chain. It has 5 tools. Let's see what's happening now. If I click on the delivery pipeline, this will tell me what's happening now. So I will see that my delivery pipeline is made of these 3 stages, where the build stage is currently running. I see the Git URL. If I click on this link here, it will show me the Git URL. So this is the already cloned URL, right? So I said, please clone my GitHub repo here to the GitLab on IBM Cloud, and this is the address of the cloned URL. And I see what happened. There were 2 jobs in this stage. The fetch code already passed. The tests, that was quick because there are really no tests running. It's just a placeholder. And I see that the build stage passed. Green color is good. It means there were no errors. And now I see now that the next stage, the containerized stage, is running. The first job, checking the Docker file, passed. I see the green check mark. That's always good. Green is always good. So all went well with that job. And now the second job is running. It's checking the registry. And if I want to see the details, I can look at the log of this job. So I'll click on this job, and this will show me the log. And the log says, it gives me some information, right? Preparing the artifacts and so on. So at this point, I can, done. So the checking registry is finished. No, it's not finished yet. It's still running. And the log is being populated on the fly. And I see now that this job has passed. The next job is in the queue. It should start shortly. Oh yes, it's running now. This job will build the container image. So let me click on it and see the log of this job. Here I can see the duration, how long it took, right? So this job is already taking 27 seconds. If I go back to look at the previous job, that one took 1 minute and 13 seconds. It passed successfully. So let's go back and look at this building of the container image job. Here I can see a lot of useful information. So this shouldn't take too long. And while we are waiting, all right, so this job completed. Now the next one is in queue. The check vulnerabilities job is in queue. Now that one will be interesting here because it will actually find some vulnerabilities in my code. You'll see the message in the log will say what it is, but it will be basically something about the SSL and the recommendation what to do about it. So if I click on this job, check vulnerabilities, this is what's currently happening. Oh, and we see the message, the check vulnerabilities failed. Now, the good news is that the color next to it is yellow rather than red, okay? Yellow means, you know, we could still go on if we want to. So let's go back to, actually, let me see if there are any additional messages here. There should be. They should come soon to explain why this job failed. So these additional messages should show up here. So rather than wait for them, let's go back to look at our pipeline again and see what's happening now. So we see that the containerized stage has passed with warnings. The yellow color, you know, immediately catches our attention. And we see what warning was that. The warning was somewhere in this job. And we see that now the deploy stage is running. The first job in the deploy stage already completed. The deployment to Kubernetes completed. So let's look at this job and see what it did. So I will click on the deploy to Kubernetes. Scroll down, I'll see, you know, a lot of stuff that is happening, including the configuration that was used here, you know, the YAMLs, right? The deployment YAML and the service YAML. Obviously, it created a service and something more about services. And if I go down, here is an interesting piece of information. It says, view the application at, and then there is an address. So this address is where our application is now available. So if I click on this address, here is our newly deployed chat room, right? So if you do that, you have your chat application, which you can use to chat with your friends, right? But let's go back and see what else was interesting here. So this was our deployment job. The next job was checking health. So this one was, you know, checking health of the pod that is running our app. All good here, as we could even see that the app was running. Let's go back and check this vulnerability thing, what happened there. So if I go back to this containerized stage and open this job, check vulnerabilities and read the log. If I go down, okay, here are the warnings. It tells me general type is generic and so on, OpenSSL, and then quite a long description with an advice of what I should do about it, and also what kind of danger I'm being exposed to. And now I can do something about it, obviously. Now, the reason this job failed, but the pipeline still continued is this. So by default, when you create such toolchain, let me show you a bit more details of this stage. So if I click on these settings and then configure the stage, I can see the details of this stage, right? So if we look at this job, click on the job, check vulnerabilities, and then scroll down to the bottom, we see that this checkbox, stop running this stage if this job fails, is unchecked. And that's why, you know, the pipeline could continue with the next stage. If I click here, you know, if I check this box, then this would be not allowed. So while we are looking at it, no, let's do something else first. I want to show you something else here. Leave page. So this is our newly created delivery pipeline. And if we go back and look at the whole tool chain, we see that we have this Eclipse Web IDE attached. You know, it's a part of our tool chain, right? So we could use that to make changes to our source code if we want to. So let me show you how you could do that. So I will open this web-based IDE. Since it's the first time I'm opening it, you know, it was just created. It will take some time. Now it's setting up the workspace. And here is my source code. Now this IDE is obviously not as fancy as VS Code, for example, right? So I would probably, no, not probably, I would for sure keep using VS Code rather than this one. But this one comes handy, you know, if I need to do something real quick and maybe I don't have my computer with me where VS Code is installed, or, you know, for some other reason I choose to do it here. It would be quicker. So let me show you how you can do this. So let's make another small change in the code. Let's make another change in our index HTML because this is the fastest. So what do we have here? So here we have, basically this describes again our, you know, the first screen, what we see when we start the chat app. So let's change this label in the form. Let's change it from display name to, I don't know, enter your name. Just to do some change. Save this, save the file. And now I want to commit this to Git repo, right? So I will go and open, you know, the root here. And in the root, when I scroll down, I get to the Git repo. If I open this, here is where I can enter the Git commands. Now I'm doing this for the first time with this tool chain. So what it just did, it created its local repository, right? Local meaning, you know, it acts as local repository, but it's still running on cloud. But for all intents and purposes, this is my local repository. So it shows me what was the change I just did. I'll commit this change and just enter the commit message here. I'll say changed the label to enter your name. And I'll click commit. And here I'll say push. And now it's pushing the changes from the local repository to the remote repository. Now, both of these are on cloud. But again, here when I'm in the editor, I work with the local repository, and now I have just pushed the changes to the remote repository. And if I go back and look at the delivery pipeline, what's happening here? is, in a moment, we'll see that the build is running again because it has sensed there was a commit done to the remote repository. The last commit was what I just did a minute ago, and now it is updating the whole pipeline is being triggered. So it's doing the whole thing again, right? So it will take a few minutes. And while it's doing this, let me show you a few things. Now, if you remember when we said in the beginning, there is a slight difference between continuous delivery and continuous deployment. You know, by some definitions, the difference is the deployment is fully automatic, while the delivery stops just before you deploy the app, right? So here, when we created this tool chain and used the template is set in a way that all of this is fully automated, including the deployment. Now, if I don't want to do that, what I could do is go into this deploy stage and change that. So I could say configure stage, and let me see where that is. I think what I need to do is go to the input where I specify the input of this stage and say run jobs only when this stage is run manually. So I'll do that and save it. And this way, I will have to trigger this deploy stage manually. Let's see where we are now. So now we are in the containerize stage. That one is running. While it's working, let me show you a bit more about how you configure these stages. So you can configure any stage, as you already saw, using the settings and what I can do here. So let's look at this stage. So in each stage, we see the input. What was the input in this for this stage? So for this stage, the input was the previous stage, which was build. And the job in this previous stage, we can see which one it is. Then we can see the current jobs. We can add a new job if you want to this stage. So let's say we want to do this. I will click on add job. And it then asks me what type of job do you want? Do you want a build job or a deploy job or a test job? So let's say I want a build job just to see what are the options I get. So it tells me, okay, what kind of builder type do you want? So by default, it's a simple builder type. That's what we used also originally. But there are some other options. You see that the options are quite, there are some options. You could use Maven or Grunt or, NPM and so on. Right? So this is where you choose your builder type. Okay, so depending on what we choose here, there would be possibly some more things to configure, right? Including, do you want to stop running this stage if this job fails? But we won't do that, so we will not add a new job here. So I'll just click on remove this one. Let's see what else we can do with these stages. So the workers are basically, this specifies where this stage is being run. So by default, the workers are running, in the environment which you configured, but you could change it. You could have your own private environment, your own workers. And if this sounds like something interesting, if you click on this learn more, you'll find out how you do that. Then if you look at the environment properties, we can see what properties are being used by this stage. So this particular stage is using, one of the properties is the Docker file, which is the name of the Docker file, right? So this, it's the similar structure for every stage, really. So I'll go and discard changes and see whether our, yeah. So this this pipeline, where are we now? Oh, right. So the container stage was finished. Now the deploy was not triggered because I specified I want to do this manually. I want to maybe, I could have reasons for that. Maybe I want to check the logs of the previous stage or something like that. But anyway, when I'm happy, I can just click on the run button and this will run the stage. And eventually what we should see in a few minutes is our application being redeployed. Now, I believe I have just one more thing I want to share with you, which is if you have looked into this Git, if you did the exercise and you looked at this Git repo of this chat app, you could notice that there is nowhere any Kubernetes deployment configuration. There is no YAML file, that will specify how to deploy this app. The reason it's still working, it has its own default configuration, which works for this app. I could change that configuration if I wanted. I could maybe want to use some other type of service or anything else. There are a few ways how I could do this. One way is I could include the YAML configuration files into my Git repo. Another way is maybe more pragmatic is this one. So let me show you that. I will go and open my cluster configuration to show you how I could do that. So this is my cluster. And here is where I can open the dashboard to show me what's going on in my cluster. So I'll click on this button, Kubernetes dashboard. And if you worked with Kubernetes before on any other platform, this dashboard will be familiar. It's really the same on every platform, right? So let's see what is running now in my cluster. So first I'll say, show me the namespace where my application is. The name of that namespace is prod. And here is what's running in my prod currently. There are two deployments, right? Because I deployed this chat app twice. And there are 2 pods and there are 5 replica sets. You can see the names of the deployments. One of them was deployed 3 hours ago, where I deployed this chat app originally. The other was done 17 minutes ago when I started this demo. So let's say I want to change a configuration. How would I do that? Well, let's do the first deployment I created 3 hours ago. I will click on it. And what I see here, I see that it has 1 pod. I see many other things too, but let's just pay attention to this one. So I can see the configuration of this deployment here. If I click on this edit resource button, this will show me my YAML, configuration file for this deployment. So here is where I can change the configuration of this deployment, right? So let's make some change. and see what happens. So let's say we want to change the number of replicas. So I'll scroll down in the configuration file to find the place where I can change the number of replicas here. So by default, there is one replica. And if you look at the background, what I see below, one pod is running, one is available, one in total, right? So let's change these replicas to 3 and click on update and see what happens. Oh, look at this. Immediately we see that now we have 3 pods in total. For a while you could see one of them was running, the other 2 are being created, but now it's all of three are available, right? So if you go here in the dashboard and look at the pods, we see that we have 3 pods named chat app. These are the 3 pods of this deployment I have just updated. And then there is 1 pod of the other deployment I just created recently. All right, so I see what's the time. We are close to the end. Now, let me just share a few things and then we'll see if there are any more questions. So a few more resources for you, documentation about the toolchains and continuous delivery with Kubernetes and IBM Cloud. And we are running also a workshop here on the same platform, Crowdcast, right? We are running a workshop on October 27. This will be a workshop about how you operate Kubernetes on IBM Cloud. And the content of the workshop is really a preparation for a badge quiz, a badge exam. So there is a badge with the same name on Credly, which used to be known as Acclaim. So there is a badge with this name, operating Kubernetes on IBM Cloud. So what we will do in this workshop is we'll cover those topics, and it's a preparation for the badge for those who want to do to get a badge, right? So this workshop will be in 2 parts. The first part will be on October 27, and then the second part will be on November 3. And here in this link, you see how you can access it. And if you will join us, then you will meet Miriam and myself again. And this is all from my side. So let's see if there are any questions. I'm looking at the chat room. I don't see.
There aren't any new questions in Crowdcast, and I'm just checking the other platforms too. We're all good. I am going to post the link to the upcoming workshops in the Crowdcast chat.
All right. Super. Thank you very much then. Thank you everybody for attendance. We hope this was interesting and or useful for you. Miriam, thank you. Back to you.
Thank you so much, Adso. That was an amazing session. I learned so much, and it was great watching the hands-on and taking part in the quiz. It was really interactive, such a great session. And there are people also saying thank you in the chat, full of praise for your session. So thank you. We're really looking forward to the Operating Kubernetes sessions with you at the end of this month and at the start of November 20th and the 3rd, I think it was.
Yes.
27th and the 3rd. Great. So I've posted the link in the chat. If you want to join, you can sign up via Crowdcast for those 2 sessions. And as Adso said, at the end of those 2 workshops, you can get a badge. So you can add that badge to your LinkedIn profile, to your email, signature, and all that good stuff. So I'm going to wrap up the Developer Festival now. It's been a wonderful week filled with lots of different topics. We've had everything from quantum to Kubernetes today, from DevOps to machine learning and artificial intelligence. We had Project Debater, and today with our Cloud Day, all sorts of cloud goodness, microservices and OpenShift, all great stuff today. And so we have shared a lot of links with you. We'll be sharing a follow-up email with links to all the workshop resources, and that will be in the chat and the follow-up email. If you would like to reach out to us, I'll also put our contact details in the chat, and you can definitely follow us here on Crowdcast. There's a follow button in the top left of your screen, or top right, sorry, if you're new to Crowdcast, and you can know exactly when we go live for all our talks and hands-on workshops. So you'll get a notification about that. So thank you for joining us. And we're looking forward to seeing you again at one of our live sessions soon. And yeah, I hope you have a wonderful afternoon, evening. And thanks, everybody. See you again soon.